I would like to start, first of all, with the objectives of this final Nautilus conference. So we will be presenting the main results that we achieved in these 4 more years of activities in Nautilus. We identified 4 main topics where Nautilus project has provided in our view the main achievements. One will be about the technologies. So Nautilus developed many new cost-effective solutions for enhancing the monitoring of the ocean. Then one of the main focuses will be also on citizen science. For instance, we established many different campaigns with citizens for marine litter collections. So we developed software and tools to be used, and we promote the public engagement throughout Europe in various use case studies. And then another important part that was the basis of our project is about the open access data, because we are collecting many data, and those data has not to remain within the simple website or platform of the project, but are shared throughout the European Archiving Center, European Marine Data Centers. And then another important focus is about the capacity building that we applied and we organized during the course of our project through 2 summer schools, e-learning modules, and all the involvement of early career scientists. Then a very important, the final part will be, let's say, the external point of view with a panel that will involve several other projects and initiatives that are currently or just being finished together with Nautilus activities. And we will be, let's say, aiming to have a look ahead after the end of Nautilus project in promoting opportunities for sustainable monitoring of the oceans and sustaining also innovations with the involvement also of several industries that have been collaborating and participating in the Nautilus project. So that's the main goal of this conference, of this webinar. So to have an overview, obviously this was foreseen at the beginning. Let's say that we have more or less 15 minutes delay now. We will start with a keynote. I don't know, hopefully she was able to connect. Zoe Constantinou, project officer from Directorate General of the Maritime Affairs, DG Mare, who has taken the place of Nautilus Policy Officer Nicolas Gebart. She will give a keynote address about the future of open ocean science. And then we will follow up with 4 Nautilus presentations divided into 2 separate sessions. I mean, 4 separate sessions into one before the coffee break and one after the coffee break. Technology and citizen science, and then the training and data access. And after that, we'll finish, as I mentioned before, with the panel. They will be open also to open questions and answers from the external. And I will introduce the participants of this panel after when we will start it at the end of the presentations. Just thanking all the participants and collaborators that we wanted to invite to this event. So besides project partners and marine scientists that are already involved in all the Nautilus activities, obviously we wanted to involve European Commission through DG Mare, various stakeholders in other ocean monitoring and ocean and citizen science activities. Obviously, a strong involvement by other EU initiatives like EMODNet, EDITO, Ocean Prediction, Coast Predict, Tech Oceans, other projects, Ocean IDS, very recent synergy were established at scope, and also something that is now very important in New Horizon and all the European projects, a focus on ethics, because this is also very important. Obviously, this is a meeting that's supposed to be hybrid, so we are around 40 people here in the room, and obviously participants from abroad. Now, I also like to introduce the final video that, thanks to our communication and dissemination leader in Nautilus, we realized based on the 4 or more years of experience of Nautilus. It's just issued recently, and we are showing it now for the first time.
The NAUTILOS project may be coming to an end, but its impact is just beginning. Over the years, our partners have reshaped ocean observation, pushing the boundaries of technology, engaging citizens in science, streamlining data management and policy recommendations. With 18 innovative sensors, more than 10 of them already on the path to commercialization, Nautilus is revolutionizing how we monitor essential ocean variables and track microplastic pollution. Scalable, modular, and cost-effective, these technologies are designed to make a real difference. A range of citizen science activities has been organized, from field campaigns on marine litter, tackling plastic pollution with the NIR scanner, to launching platforms like the Nautilus Citizen Science app, Marine Creature on Zooniverse, and Alga Warning app. Data is freely shared via the Nautilus data portal and integrated into EMODNet, giving real-time access to researchers and policymakers. 2 summer schools and 9 e-learning modules have trained early career scientists and marine specialists on marine litter, covering topics like international treaties, sensors, data management, and citizen science. As the project concludes, its legacy sails forward. With state-of-the-art sensors, citizen-powered initiatives, and a commitment to democratizing ocean science, Nautilus has set a new course for the future of marine observation.
Mm. Yeah. We should have done it in the beginning. Okay, let me check. Is Zoe Costantino connected already? Oops, if not. Okay, while we're waiting for Zoe to be connecting, sorry for this, because we had to skip to a new link. We can change the order and we can start with the Nautilus presentation. So we will be starting with Catarina Lemos from SEIA, one of the partner Nautilus, leader, technical innovation manager of Nautilus, and in fact she will present the various cutting-edge sensor technologies. You can start the presentation.
I prefer to stand up.
Yeah, I can turn this my sharing. Okay.
It's good? Okay, that's fine. Okay, so good morning, everyone. So I'm Catarina Lemos, as Gabriel said. I'm the Technology and Innovation Manager of Nautilus and also Project Manager at SEIA. SEIA is an engineering product institution that is part of Portugal in Madrid. So I'm going to speak about the cutting-edge sensor technologies that were developed in Nautilus, like Gabriel was mentioning. Okay. Okay. So just a few 4 points before introducing you to the several cutting-edge technology that we have developed in Nautilus, and we are just sharing one of these two booklets of these so that everybody can take a look. So to develop cost-effective instrumentation for ocean observation, as it was mentioned, for a wide range of essential ocean variables, to integrate these technologies into platforms, into large-scale demonstrations that I'm also going to share a bit because I only have 20 minutes, and to contribute towards the democratization of marine environment to unlock the critical knowledge contained in the ocean, so that we can understand the mutual benefits of marine observation. So to start everything with an example, because it's easier since many of the people online, most of the people in this room, they are aware about the work that we were developing. I wanted to start with an example. This is a very local example because it is about a product developed in Portugal and with Portuguese institutions, okay? So Manta is a product line that has been developed for a long time and in collaboration with Oceanus, Imar, and the team is here also in this room. And it's focused on toad tagging devices, non-invasive and with low impact. So when coming to Nautilus, and there was a need, this is the point, there was a need to improve what we already have that usually has the recording video and other capabilities. So there was a need to register activity and habitat info. And this, in this case, was dissolved oxygen, as oxygen is one of the essential ocean variables. When we come to this moment, we have the process of Nautilus. So this is how we managed to have this. This is what George, Bruno, people, the team are deploying at the ocean and collaborating when we are developing this solution, okay? So this is one of the products that were developed in Nautilus. And this happened with every other product that we have here and many others. So there's an Nautilus innovation process that includes the go-to product. So the way to get to this product is really nice. And then the go-to market. That once we have the product and the product is working, so after all the demonstrations, we can just take it to market and think about how can we sell it in the future. So before explaining details, let's go underwater. Yes. And this is a video from Imar. I don't know if you want to mention anyone that made the video. Maybe it's you here. I don't know. Someone, but it's really nice. So, okay. So this is an amazing moment. But to go until this moment, you need to work a lot. So more than 4 years of work, a lot of a background in collaboration. And this is important to understand. So how did we do? So for all products developed in audio, so for all cutting-edge technologies, we have the definition of gaps and needs, and I explain you what was our goal, to have the dissolved oxygen to be measured with this Manta, the product line that we have. And we have also the general Nautilus technical requirements, and they work for every product. So as compact as possible, cost-effective, and low energy consumption and platform independent. This was all the 4 characteristics that we asked partners to consider while developing the technologies. But then we have the concept, and then we have the needs and requirements, and then we went to do all the process during these past years. So we went from development and integration, so we need to have a concept, you need mechanical integration, electronics integration. In this case, we don't have sensor development, but for many, we did have sensor development. And then we had also calibration and validation activities, and they include several partners. Hyperbaric chamber testing, because this product is rated for 2,000 meters, so we are not just going to try 2,000 meters. Scenario testing locations, and this started with Azores, but Imar and Oceanus team took it further, and they were also in Colombia, and they will be Indonesia. So, and then we had facts, issues, and some other solutions, as water leaks, several that we solved, redesigns of engineering, several that we solved. We have a maximum depth of 1,240 meters with one tag, and the maximum duration on water of 280 hours. This is because they were tagging migratory animals. Of course, they don't know, but then they had the support from the Portuguese Navy to collect the tags. So everything, this was recorded also by FTPSOs, and it was really nice, this activity. We also had some trigger fish bite, and I have it here, so you can just take a look. I think it's curious. So then sometimes you just get a phone call and say, hey, an issue. And sometimes it's just a fish. And then we are ready for deployments. And from all this, we just collect the data and we share the data. So this is not only about one product, this is about this full innovation process. But because I only have 20 minutes and now you understand the process, I'm just going to take you through the way that we found to share the go-to-markets. So there's always a value proposition. It means that each technology that we develop has a value proposition. So why it matters, what was the gap, what's the need, what we are doing, what we aim to do with this sensor, and why is this different from the market? And then for these, we need to have information like merchandising to explain people. We need to have an indication about the technical performance, where we did the demonstrations and with which equipment, and then our commercialization strategy, because don't forget, not all sensors are developed by companies that sell. Some are developed by institutions, academia, and they need to find a partner to commercialize. So this is what we are going to have in the following slides for all products. I'm not going to read all the text. This presentation is supposed to be delivered to everyone. So I'm just going to jump and touch a few points that I think are interesting to understand how complex and I believe outstanding is our Nautilus results. And thank you for everyone that is here that contributed to develop all those sensors. So this is what we have. In the case of Manta Nautilus, that you know, you were underwater with us already. So we have the value proposition. We have a non-invasive towed marine animal device for sharks and mantas that measure dissolved oxygen, causing a minimal drag to animals, easy to deploy, and up to now, 100% recovery rate, of course, thanks to the wonderful team that is on water and the equipment that has positive buoyancy, as you can see here. We tested in Portugal, Colombia, and still in June in Indonesia, and this is going to be commercialized by say with Imar as a partner, a commercial partner. Okay, so now we have, you know how we are going to organize and explain, and these are all the commercial products, okay? So Nautilus developed several instrumentation. Not all is commercial at this point, but we have already 11 products that are commercial, okay? To demonstrate these, we use several testing platforms from landers, ASVs, UAVs, mooring buoys, AUVs, research vessels, ships of opportunity, and cargo floats. We also tested in several oceans: Atlantic, Indian, Pacific, and Southern Ocean. I think this is quite amazing. We have also data shared from demonstration activities, 55 data sets types up to now. And then we have market competitor analysis. Why? It's not only about developing and delivering the sensor. Then we need to understand if it's still different 5 years after submission and what's the cost benefit. So we considered 36 other instruments to compare, and we asked 30 prices quotations. So let's jump into this sensor developed by our Greek partner, HCMR. So this is the deep ocean radioactivity sensor that in the end ended up like being also a data logger. It is a solution for cost-effective underwater in situ gamma ray spectrometry for deep ocean up to 3,000 meters. It was already tested in Nautilus up to 2,100 meters. And we have also commercialization intention from Horst company in Greece. They are working on joint initiatives, and they are also working on a license agreement. This is very interesting because it enables radioactivity profiling along the depth and correlation with CTD and long-lasting deployments of 25 days. And as you imagine, this is very important for offshore. All these leaflets and information is also available on websites from Nautilus, okay? And then we have another one, and if you have any question, we can then just ask Danilo and Matej that are also here. This is another instrument developed in Nautilus. This is up to measure conductivity and temperature and depth up to 2,000 meters. It was tested until 1,600 meters in Portugal. And this is an innovative and low-cost sensor chip for conductivity and temperature. This is very promising in terms of the future. And we consider this to be more reliable and cost-effective production and maintenance for the future. This is at the lander after 1 month deployment. We also have from ESO a sensor to measure dissolved oxygen. So this is a very compact and high resolution oxygen sensor, the cheapest in the market, since I told you we compared this with other competitors. It's flexible because it can adapt to several other probes, and they use MKE, that is a company, a partner also in Nautilus. They use the housing to just simulate already this. And also MKE shares some intention for commercialization, which is very interesting because ESO is not selling. Then we have another dissolved oxygen sensor. So this one is really from NKE, but they find an advantage to have intention in commercializing the previous one and this one because they use different types of luminescence quenching methods. This is interesting to be addressing all the points because the target is to have the most cost-effective sensor for these measurements. What we have, this is suitable for aggressive and extreme environments. And it's very interesting because from the past 2 years, this was being tested with fishermen communities. So they have intense testing and demonstration that you can consider. And for this particular sensor in the final slide, I'm going to share a good news to everyone. Also, MKE is developing the same side, so suitable for aggressive and extreme environment, working with fishermen communities for the past 2 years, and also the same Wi-Fi and the water data logger for these other parameters. Okay. Then we move to the last solution developed in Nautilus for from NKE. It's a silicate electrochemical sensor. So this is a bit more, it's different from what NKE is used to do, and I think it's a step further on their own portfolio. It's a partnership with CNRS that is working together to develop this sensor. This is easy to use with no reagent bags. And this is very different because no other competitor has something like this. So we are changing the way that they can measure silicate, okay? And due to this big change, there is no lifetime limitation, okay? And this is very interesting. It has been tested with Argo floats on the Mediterranean Sea. And of course, it's going to be commercialized by NKN after an intellectual property agreement with CNRS. And then we have the submersible sampler for nanoplastics and microplastics. This is developed and to be commercialized by another company that is partnering Nautilus, that is Subsitec. So what is the point here? This is to provide automatic sampling or up to 6 months on offshore. So imagine this is very interesting when you want to do this data collection and we need to do it with a buoy. This is exactly what Nautilus was doing, aiming with the demonstration. So using HCMR, that is our Greek partner monitoring buoy, so they took it to the ocean and it's there for a long time just to prove that it works okay. This is already available on Subsitec portfolio leaflet, so the official one from the company, and it proved to have strong interest in the past ocean science meetings in UK. Then we go for another one. As you see, we have a lot of results, and this is just amazing to have this opportunity to be part of a project like this. So this is the click and sound recorder. This sensor, the following one, is developed by Aquatech and is here in case someone has any question afterwards. So this is a different sensor from the others that I was explaining about. This is indeed a combination of two project results in one commercial product. This is a dual function passive broadband recorder for marine mammal observation and soundscape analysis. And as you can imagine, this is quite interesting right now with the Europe and the wind offshore that we are so much working on. This has a unique capability of providing click-triggered sound recording. and the price point is lower than competitors. And this is also very interesting. Don't forget, cost effective was also one of the topics that we had in Nautilus. They have a lot of testing locations, as also a lot of brokerage opportunities participation. We have the offshore of Italy and Greece using the CSV, that is this picture here, also monitoring buoys and work with the Swedish fishermen communities. Then we move to the second aquatech sensor developed in the scope of Nautilus. That is the Aquastat. It's a high-frequency profiling sensor for sediment studies and marine biology. This equipment, it's price comparable with other acoustic profiling instruments, such as Dopplers, and they are not the same. It's the only multi-frequency instrument capable of determining profiles of suspended loads and mean particle size. It's tested with the lander in Portugal, and it's going to be commercialized by Aquatech. Then we go to the last one. It's also an animal tech, like this one, but this one is for sharks and mantas, and the other one is for seals, elephant seals, and also for turtles. So what we have here, this is also new to market, like this one, this tag. They are the only available equipment in the world to do this kind of tagging like we are doing, okay? So it's a marine animal-borne tag with satellite transmission up to 2,000 meters. And this is the first commercially available. It's the commercialization is made by SMRU and CNRS, and Christoph is also here if anyone has a question, is deploying these on the Southern Ocean. This is an essential tool for obtaining data, mostly from remote oceans and coastal areas. And this has efficiently been working using Southern Hemisphere for the past 20 years. And this is how we collected, everyone, but maybe Christoph team, collected data from the Southern Ocean to share with everyone. So I told you not everything is going to be commercial in the end, but everything provided some benefits in the scope of Nautilus. So we have other results that are not commercial. We have the microplastic sampler and sensor that might become commercial soon if we find a commercial partner. And then their joint action between the two that will develop a microplastic detector system that is under a lower TRL. And then we have carbonate sensors, phytoplankton sampler, and downward-looking sensors that were also results from Nautilus, but they are not considered commercial because they use also some components off the shelf. So I would say that I closed with the 18 cutting-edge technology that we developed in Nautilus. This, as you know, are all the leaflets that we have. And from the market point of view, we have 11 commercial products and 2 are new to market. We have 100% of the Nautilus technologies providing benefits for the ocean monitoring. So imagine we are just taking to the market 11 products that really make a difference when we think about the ocean observation. And this is very important. All products were present in 9 brokerage opportunities. So as you imagine, sensors were being used during demonstrations on an offshore buoy, on an Argo float, on lander. So we just took the leaflets and we explained everyone. Most of the times we also took some sensors. For example, we took the tag almost everywhere. We took, Jana took parts of the sensor also to some exhibitions. Aquatech was taking part in many of them and NTE also. We have over 200 recorded interactions and they were all invited to this event. And we have also early sales. It means that Nautilus is not yet in the end, but we already have sales from NPE for these 2 sensors that I mentioned before, which is very interesting. It's a proven validation from the market in terms of how they are important from price to benefits. And many more will come. So we are sure this is just a process. It's supposed that sensors development take their time and their validation process. So we expect many more sales to the future. If you want to know more, you can just click here when you have the presentation, or you can just go to the site and see the results. All results are described with leaflets attached. And thanks again to everyone. And then if you have questions in the end.
Yeah. Questions. even for the remote speakers. Okay. Okay. So Zoe should have been able to connect, and most probably she's also able.
Hello.
Hello, and also Eva Zika, you're also connected.
Yes, I'm here. Hello.
Hello. So share screen here. So Eva is a new Nautilus project officer, and she will be also attending tomorrow's Nautilus meeting, internal consortium meeting. And I will leave the floor to Zoe Constantino, who is a project officer from DG Mare. Zoe, can you share maybe your camera or?
My camera is on, but I don't know. You have to pin it somehow.
Okay,
Yeah,
okay,
this is
okay.
it.
We're seeing it.
Great.
Just
Hello.
let me-
I'm here to thank you for the invitation. I'm here to be in the place of my good colleague Nicolas Aguibarth, that is a policy officer in RTD working on marine knowledge and ocean observation. And I am Zoe Constantino, I work in DG Mare in marine knowledge and ocean observation and other parts of marine knowledge. Thank you for the opportunity to say a couple of overarching words at the beginning. It was very fascinating to see in such a nice consolidated manner the presentation of the technologies that you have developed and further developed during Nautilus. This is extremely inspiring, extremely important, extremely fascinating. It's very nice to see the expected results and how they are ready or almost ready or in the way to go to the market. It's fascinating to see the reaction of the market. That is also very essential. And it's fascinating to see the demonstrations that you already have provided and the possibilities that these are creating for ocean observation. So the general idea of this talk is to speak about the future of ocean science related to ocean observation and to data management and citizen science. And this is a difficult conversation these days, the future of ocean science. The geopolitical changes and the changes in the way that we understand the usefulness of science in Europe are showing a trend that is not always so positive. Is there any chance that you can mute the room?
Sorry.
Is there any chance that you can mute the room because the sound from the room is a little bit affecting my line of thought? So I was saying that we are in a moment that the geopolitical changes are finding us all in the scientific community and in the policy, in the European part of the policy community at least, in surprise, in frustration, and with a lot of question marks about where ocean science is going and where ocean observation is going. We have been facing problems in the coordination of ocean observation in Europe for decades now. We know that the funding of ocean observation is precarious. We know that a lot of our technologies are based in what the US market has to provide. So we are not autonomous, and we still lack the observing networks that will allow us to produce the ocean science of the future. At the same time, we are in a point that society demands more action regarding climate change and demands more involvement also in this action and this sharing of the knowledge. And you can see this from the increase of interest regarding citizen science. You can see that there is an increase in the interest that societies have in how they interact with the ocean. Yet the political interest remains a little bit not yet motivated to take action. This is something that probably is going to change. We are coming now in a period that the European Union has committed in a way to go forward with what we call the Ocean Pact. Maybe not the most ambitious initiative of all times, but it hides behind it a lot of opportunity for marine knowledge, and all the basis for marine knowledge is ocean observation. Now, there are multiple things to be discussed here with the geopolitical changes and the understanding that we are not as autonomous as we want, and we are not as leading as we want to believe in the field of ocean observation. And projects like yours bring this into good understanding and create opportunities. We need to step up how Europe is participating in the global ocean observing landscape. We need to coordinate better how we conduct ocean observation in Europe, how we sustain ocean observation in Europe, how we make ocean observation more detailed, more cost efficient, and how we use all this in order to enhance the technology market in Europe of how we produce sensors for ocean observation, and how we keep this capacity in Europe in terms of creation of technology, of creation of innovation, and in the end of the creation of a market. So from this point of view, your project is extremely important, yours and others. There are tremendous developments that can be used, and we can take advantage in the next period of time. And hopefully this is going to be actually a possibility. We are in a historical moment that Europe has to step up these efforts. The United Nations Ocean Conference is coming. The commitment from the part of the European Union is there. And this is exactly an opportunity that we need to take into consideration and to take advantage of in the next years. That would also mean these advancements that may come in ocean observation, and they come from technological projects like yours, are not operating are not operating alone. They are connected with our data management systems, our capacity to operate systems that serves not only Europe but the world. They are connected with the capacity to create digital applications like digital twin oceans that are the hot kid on the block lately, and everybody's talking about them. But everything is related with our capacity to produce ocean observation. As a community, as a marine knowledge community, there is also an obligation besides an opportunity to develop further solutions. And this obligation is an obligation towards ocean science, and also towards the European idea of how open science should be, how ocean science should be open and should be accessible to all. And this obligation of the community comes from the point that calls for collaboration. Calls for collaboration and a European collaboration, but also openness to the world, and effort to consolidate a very complicated landscape as it is the one of ocean observation. Consolidated action, coordinated action, demand from the stakeholder community for better policy regarding ocean observation is something that will allow also the community to take advantage of the technological developments and create a market that, of course, if a market is created, then more projects like yours can be put forward and more developments can come forward. As you know, the European Commission aims to put forward an initiative to coordinate ocean observation and support ocean observation. This remains an ambition that is not lost, and we hope that the next years it will become a reality that will support all of you in the community of ocean science and the ones that are developing ocean technologies. And with this, I don't have much more to say. What you have presented until now and what I have seen as deliverables of the project are truly impressive, and we hope for more.
Thank you, thank you, thank you. Just trying to hope I'm not doing any damage, but showing because we have some issues also with the camera. So it's yes, and then sorry, being only. Thank you, Zoe, for your kind and very, very interesting words that are, I mean, they were covering, I think, most of the topics that we are also working with in Nautilus, from data, citizen science, and technology. So very, very many partners interested also in the future for future calls and future opportunities to be involved. And we already started some of those activities thinking about the legacy of Nautilus project. So hopefully things will be not finishing just now for this consortium with the Nautilus project, but will be going on with the further opportunities and future initiatives.
Hopefully this is only the start.
Yeah, hopefully. Yeah. We want to believe so. So thank you, and we are now continuing our agenda with a presentation from Eva Chatzinicolaou from HCMR. She is the leader of citizen science activities. Where is your educating, right? No, this is the capacity here. No, I didn't open it. Citizen science innovation entrance. There's nothing to just do. Okay.
Hi, everybody. My name is Eva Chatzinicolaou, as Gabriel said, and I'm a researcher in the Hellenic Center for Marine Research in the Institute of Marine Biology, Biotechnology, and Aquaculture, which is located in Heraklion in Crete. This presentation is about the citizen science innovations as part of the Nautilus impact. The main objectives of these innovations were, of course, to create awareness for the marine environment to the general public and to offer additional knowledge and to enhance ocean literacy. We believe that this will empower communities to contribute to ocean research, and that will also bring experts and volunteers together. We try to train the citizens to collect quality data and, of course, to promote the fairness of this data. And of course, one of the main aims of Nautilus project was to develop some entertaining and innovative citizen science tools. We have a big set of tools finally, and we have used most of them with different groups of volunteers and citizens. I will talk in detail about each one of those. This is just a list. It's the Universe project we created, the marine creatures, the protocols for beach cleaning campaigns, the NAR smartphone scanner, marine litter trackers, collection of data on fishing vessels, the alga warning kit, the use of Nautilus sensors in citizen science activities, the citizen science app, of course, and the Nautilus portal, and of the creation of ethics consent forms to guide all this participation in our activities. First of all, it's an online citizen science tool. It's the Universe platform, and it's quite famous for volunteers that participate in citizen science projects. We have created the project for annotating underwater images, and it's called Marine Creatures. And the volunteers are able to study marine biodiversity, and more specifically to identify benthic organisms on underwater photos. and collect data in that way. This project was launched in September 2022. It's still ongoing. We have almost 1,400 volunteers, and we have reached more than 19,000 contributions up to now. There are different taxonomic groups of organisms that have been identified, such as macroalgae, sponges, hydrozoans, sea anemones, corals, polychaetes, bivalves, and many more. The photos were collected from 3 different habitats: ports, natural sea caves, and artificial reefs. And we have created a field guide and a training tutorial to help the volunteers to use this project. And while they're working on it, there are pop-up out windows with photos and short descriptions for the taxonomic groups that they want to annotate. We have also included some tips for the groups that are easily confused, and the volunteers can use filters to narrow down their search according to different colors, forms, shapes, or the status of the taxonomic groups they investigate. After 18 months of this project that it was running, we collected some data and we wanted to see how things are going. So we did some statistics. We had about, as we said, 1,400 users and more than 19,000 classifications. We saw that the average number of classification per user was about 13.9, and they were spending about 5 minutes and 27 seconds for each annotation. This was a way to present their level of dedication. And we also wanted to know if there are some taxonomic groups that are more time demanding or more difficult. So we analyzed how much time people spend for each taxonomic group or how many mistakes they can do. So there are some groups such as the barnacles and the sea anemones that they are easier and people can easily identify them. But there are others, more complicated forms that people do not know well, such as the bryozoans, the sponges, tunicates, that they can do more mistakes, which means that we need to further support them for these annotations. Then we have another activity for Nautilus. A big part of our citizen science activities was the beach cleaning campaigns. We performed 24 campaigns in 9 locations in Crete. This lasted for 36 months. Some of them are still ongoing at the end of the project. We've involved 15 schools from the primary and secondary education, and we have more than 1,000 participants, and which have collected and identified more than 20,000 items of plastic litter. These campaigns included presentations in the class, hands-on experiments, and of course, they concluded with the beach cleaning campaigns, the collection and classification of plastic litter according to the EMODNet categories, the J-code list, and sometimes the students, especially the younger ones, were using these pieces of plastic, and they were creating items for everyday use or like more artistic items. Our target groups were students, of course, the general public, some citizens associations, and the NGOs. Similar activities with citizen science and beach cleaning campaigns were performed with the NIR scanner. This is a near-infrared scanner. This device is able to differentiate the polymer type of plastic fragments, plastic items, and give us an additional insight of which are the potential sources of this litter. It's performing well for mesolitter, which is often confused by marine organisms as food. So it's an important problem. What our partner NIVA did for this activity is to develop a database with 7 virgin polymers and furthermore 400 household items that were focused on the most common types of polymers. And then the citizens were able to use this very simple device. They just place it on the item, and the result of the polymer type appears on the screen. it's recommended to perform 3 scans per item to have a more secure result. This scanner has been used in several beach cleaning campaigns and even scientific cruises where students and citizen science participated. And these protocols have been also integrated in several teaching initiatives such as the Plastic Pirates and the Inspiria Science Center. Also, NIVA is currently in progress with a collaboration with the Oslo Met University, and they plan to construct a low-cost device similar to this one, which will use an open source software. This will be assembled by the students themselves, and it will be very easy to operate and very cheap, of course. So these are steps for the future. Another activity was the construction and operation of the marine litter trackers. These were performed by CNR. And these trackers are used to study the dispersion of floating litter entering the sea from the mouth of 2 rivers in Italy, Arno and Magra. And these drifters, they are low cost. They are equipped with a GSM real-time tracking system, and they are using open source technology, and they are constructed by the citizens themselves. The students released these trackers on the sea. They were able to follow them for 10 days online. And in total, CNR performed 10 dispersion experiments in 2 years with a total release of 46 drifters. This data can be combined with models, and that will give us very important results to understand the dynamics of litter input in this Pelago sanctuary area. This activity has been also included in a very nice Italian documentary called The Luna sul Mare that was very interesting for even for young kids to realize and understand the problem. Another initiative we recently performed was the collection of marine litter on professional fishing vessels. These are commercial vessels operating in the Adriatic Sea, and they participate in the Adrifos infrastructure. They are equipped with sensors, some of them of this project as well, and they transmit daily reports with georeferenced data, including environmental parameters, the tracks of the vessel, the quantity of the catch, the size of the species, and some meteorological information. So the fishermen were asked if they would like to also collect some data on plastic litter that they might encounter during their daily catch. And they agreed. So they had the opportunity to add this data using a graphical user interface, a NI logbook, the one they use to register their daily catch and all the other data. So the data that were related to plastic litter included the date, coordinates, the vessel and the whole ID, and the type of the plastic litter, which usually was parts of fishing equipment, plastic bottles, and containers. Also, a very nice device. It's the algal warning kit. This is a kit that includes a method for citizens to collect samples on the beach and monitor harmful algal blooms, which are very important and could pose a threat to human health and to the marine ecosystems. The citizens can collect small seawater samples from the field. They put the samples and in the microscopic counting chambers, and they use some specifically designed lenses to observe these samples using their own smartphones. They can take photos, and they can upload these photos together with some data, such as the coordinates, the location, and the characteristics of the samples. They can upload this data in the Nautilus data portal using the Citizen Science app. We also had the opportunity to explore some of the very scientific sensors that were developed within Nautilus in citizen science activities. This was not easy because these sensors are not made for citizen science activities, but some of them had really nice and very interesting results, and the volunteers were really enthusiastic about using them. So we managed to use the passive acoustic broadband recording sensor from Aquatech that can be used for monitoring noise and underwater soundscapes, usually used for sea ice dynamics and seismic events and acoustic impacts of human activities. The citizen science activities were performed by local recreational divers in winter and spring in 2024 in Crete in 2 locations that had a depth of about 9 to 10 meters. Very recently, we also managed to use some sensors for dissolved oxygen and chlorophyll from NKE. And the divers mounted these sensors on their BCDs while they were diving for leisure. They set it up the acquisition settings through the web application of NKE. And they performed this activity in spring 2025 in Italy, in Ancona, at a depth of 4 meters. All this data have been uploaded in the citizen science portal in the Nautilus website, and we've used the citizen science app, which is able to upload the data and images from these campaigns and make them available in the portal. There are different layers of data on the map that you can see in this web portal, different layers, each one for its type of citizen science activities. The app can be used for uploading data real time on the field or later, and it can also give the GPS positioning either automatically or manually. You can use and you can download this app and use it after filling out a contact form and receiving a registration. And there is also a user guide available. The creation of personal accounts, of course, takes into consideration the ethical issues and GDPR. So following all these guidelines, we have uploaded data from 12 bits campaigns that took part in the first period, 2022 to 2023. These data are already available in the EMOTNet database. We have also submitted the next batch, and we are pending for their publication, and we have 4 more to submit from the last year of the project before our end. Recently, a web browser version was also developed for the Citizen Science app, which facilitates data uploading, and it is also enriched with data editing functionalities. For the Nautilus portal, there is a map developed where the users can see all the campaigns as data points on the map. They can select and combine different layers to activate specific data. And they can, through a pop-up window, where they can see the full data set and possibly images that are available. They can filter the data according to time period and location, and other filters such as the type of the plastic item, the sediment type, the weather, or even the contributor that offer this data. And users are able to create reports with full data tables and several graphs. Some of which you can see here. They can have tables with types of plastics, number of plastics, and percentages. They can have bar charts or pie charts with a distribution of plastic litter in different locations and years. There is also a very interesting aggregated map with georeferenced charts for plastic litter categories for the different locations that can be shown all together. And there is also color-coded pie charts for showing the contributors and how active they were for these activities. One addition to this citizen science app was algorithm that it is based in artificial intelligence. We call this a plastic classifier, and this has been integrated in the Citizen Science app through a Dockerized container. It is able to automatically detect and annotate plastic litter. Basically, it started using aerial drone images. So the users could estimate the amount and the types and the location of litter. But the aim is to train this algorithm to use photos collected by citizen scientists and use this input as a way to further train this algorithm to be able to annotate a different group of photos as well. This data can give an insight to the detection and quantification of plastic waste, and finally to the identification of the hotspots of marine litter in an area. Finally, we created ethics forms for all of our citizen science activities. We wanted to be in compliance with ethical standards for the involvement of humans in scientific activities and to guarantee a free and fully informed participation for all the citizens. These forms have been created for adults, for all the activities that include stakeholders and professionals and citizens or students, university students. And there is also a different type of form for younger kids under 18, which was used for the school students. These forms have been produced in 4 languages, in English, Greek, Italian, and Portuguese. And we are also writing at the moment a white paper with a big group of people, which is based on these forms, and they're used in the different types of citizen science activities in Nautilus. In conclusion, the target groups we involved in our activities were school and university students, citizens, NGOs, and the general society, of course, stakeholders and professionals, and early career scientists and academics. The benefits we gained were that during these activities, we were able to collect a broad pool of data and to perform large-scale research that otherwise wouldn't be possible. And we had the opportunity to use cost-effective and time-efficient means. This is important because we managed to engage people in research, to engage them in contribution to discoveries, and to give them a sense of accomplishment for their own environment. And that resulted in further fostering public trust. In the future, we expect to use these protocols furthermore to extend our networks of schools and initiatives such as the Plastic Pirates and more, to use devices and tools that we can furthermore lower the cost, and they can make them even more easy and friendly to use. We hope to enrich the Citizen Science Hub with additional functionalities and the data portal with additional tools. And we always have in mind to produce fair data and good quality data that can be available to everybody. So that's all from me. Thank you very much.
Yeah, and here you have also a nice slide with all the people involved that you may be wanting to contact for taking getting in touch for the various many different activities. So thank you for this. So you get a first glance about the technologies, and then another very important focus on the citizen science. Those are not unlinked because, as Eva pointed out, many of the technologies, and maybe even more in the future once the technologies will be more mature, have been employed in the citizen science activities. Okay, so now we are taking a short break, coffee break here. For the remote attendance, please stay tuned. We'll be back in 15 minutes, let's say around the hour and 40. So 12:40 here, 14:40 in Central Europe, and we will be following the other aspects, so the data presented by Antonio, and capacity building and communication activities from Sandra. We'll be back in 15 minutes, more or less. Thank you. Sandra Sa, Executive Director from Eurocian and leader of communication and dissemination in Nautilus, will be, I leave the floor to her to present the capacity building and training in Nautilus. Sandra?
Yes, just try. It's here. Hi, everyone. As Gabriele was saying, I'm the work package 10 leader on the communication, dissemination, and outreach. But I'm also the leader of the task 12.3 that is dealing with capacity building connected to the European strategy for plastic in a circular economy. And we have delivered and supported the development of 2 summer courses, and that's what will be telling you about today. So first of all, I would like to discuss with you and guide you through the importance of the capacity building initiatives. As we see it, it's a way of empowering the individuals with essential skills by connecting crucial skills to effective marine research and innovation. Also, it facilitates knowledge transfer by showing off the technology that has been developed on the project as a new trend and disseminate among a broader scale of intervenience. Also, it will address skill gaps in emerging technologies. As you know, Nautilus is an innovation project, and lots of the technologies that we've been developing and upgrading during this project are the state of the art. Also, it promotes the sustainable practices by encouraging the sustainable use and increasing the stewardship of the marine environment conservation and responsible research practice, as you have the little flyer from Katarina there. And it's also a way of engaging more diverse audiences, because as you know, we have not only the summer courses produced, but also e-modules. Okay, so how we have taught this course? We always believe that doing is better than saying. So we have organized this course with these 5 principles in mind. Hands-on training, so we emphasize the learning through experience. Also, whenever possible, we try that the theory meets the practice. So every time we have a theoretical knowledge being transferred, we try to have a specific case where you could practice. Also, we have delivered several case studies, and as you will see, the course were a little bit different because technologies were at different stages of development at the time they were delivered. Then, as a new trend, and as Zoe was mentioning before, Europe is demanding for more involvement of citizens on the science, and we have already introduced our students to citizen science and why it is important. And then finally, of course, we have, through the synergies we established during these capacity building initiatives, stimulated the interdisciplinary collaboration and also collaboration with other institutions that are doing or trying to do the same things that we are doing. So we had 3 main target audiences. We firstly aimed this for early career scientists and marine technicians. And those were the ones that were attending our summer courses. So it included graduate students, professionals that were starting their careers, environmental engineers, biologists. So we had a lot of people, different people with different backgrounds attending. Additionally, we decided at the proposal stage also to open this, as this is very connected with citizen science initiatives. Why not produce materials that could actually at least grasp what we were doing and how they could use it? So we have produced 9 e-modules that are available to everyone that wants to learn from them. And they are on YouTube channel. There is a more accessible channel to citizens, and also through the website of Nautilus. And why have we thought that this is important? As Zoe said, the project officer, oceans are under-monitored. And especially, of course, in deep sea areas or remote areas. So advanced technology and skilled professionals equals better environment stewardship. And Nautilus aimed exactly that by democratizing science to bridge the observation and skill gaps. These initiatives also had the recognition of the United Nations Decades for the Ocean. It has been endorsed, both the modules, the training through the modules and the summer courses. And it signifies that we are committed to advance ocean science. Also, it supports the SDG 14 goal to promote responsible and sustainable management of the ocean resources. And it was recognized that it promotes innovation, training, and knowledge sharing. So let's start with the overview of the summer courses. We had 2 summer courses, as we said. Those summer courses were organized with the Ocean in collaboration with HCMR and NIVA. So, and these were the main partners involved. Of course, all of the partners of the consortium that were the developers of the technologies, also the data management part, were collaborating to these summer courses. So the first one was in NIVA in Oslo, and the second one in HCMR. They were aligned with European strategy for plastics and circular economy, because this work package was devoted, as Evan mentioned before, to this. But of course, we focus more on marine litter, but also we took the opportunity to showcase the sensors that we have developed, discuss a little bit about citizen science and policy. So, as I said before, our curriculum was composed by immersive training experience, and this training experience went from theoretical classes, lab work, and even going on board of research vessels where we have the opportunity to deploy some sensors. Also, as I said before, the topics covered went from policies, treaties, information how to manage marine litter, advanced sensors that have been produced not only in Nautilus but on other initiatives, and critical areas for ocean science. We have combined lectures with fieldwork, meaning labs and seafront and on sea experience. And as said before, it's not only about classes. We also wanted for people to have a good experience when coming, because research doesn't need just to be the boring lab work or technical language. We wanted to provide a forum where you would gather networking opportunities, you would collaborate experts and peers and have everyone exchange information. And then we had the cultural exchange because they were very different locations, Oslo and Crete. We had the opportunity to immerse them also in the local culture and have them do some nice activities. So the first summer school, as I said, it was in Oslo. It was at the beginning of the project. The team was more focused on marine litter because we haven't had so much technology to demonstrate at that time. And we also collaborated with other institutions from Norway to showcase their technology. So we had theoretical part and political part at NIVA, and then we moved to Oslo Met University on the Oslo Fjord. We had 7 participants attending that from 25 applications. As I said, the theoretical classes were taken at NIVA, and then we moved to the Oslo Met and the Oslo Fjord. And then we have a module of data analysis kindly provided by ETT, where they analyze a set of data sets and understood what is the connection with the policy, how we can use it to influentiate the policy. The second summer school was in Crete, and at that point, yes, we had much more technology of the project to showcase. And it was, of course, focused still on marine litter because it's the point of this work package, but we had a lot of technology to showcase there. We had 10 participants from 51 applications. And at this point, at this location, we had a very nice experience of boarding the Filia research vessel, kindly provided by HCMR for this summer school. So after having these summer schools, we decided to make an assessment on the feeling and likeness of these initiatives. And the impressions were really satisfactory. They were very happy with the structure of the courses. They liked that they had experts that were accessible and to whom you could establish some kind of dialogue, and they kept the contacts of everyone in case they wanted to proceed. The hands-on training, it was the most relevant part for them, and they were very happy with these outcomes. And they really appreciated the interactive sessions, the networking, as I said, and collaboration. What worked well? Practical demonstrations with sensors, specifically the ones for the microplastic samplers. They liked the peer networking, of course, and exposure, because it was very cultural in the end. It was, again, not just the technical training. And they liked the strong blend of the theory and the applied marine science. The areas for improvement and recommendations, they mentioned more field work because, you know, you can just do so much. And it was a 3 days course. It was not possible to do more. They would like to have access to pre-provided data sets so they could actually understand what's behind it. They would like a little bit more on the marine policy, the plastic policy. And they would like, that's one thing that we really missed, to have more time for question and answers, because it was so compact, the course and the curriculum, there were little time for people to actually pose questions. So after that, we thought, why don't we extend to other, sorry, it's missing something here, to other groups this training, because we are talking about citizen science. Why not start engaging other target audience like citizens or policymakers and make them understand that science is for everyone, not just for people working on the lab. So we have provided 9 modules that are 3 minutes each, and basically they explain at a high level what we are doing here. They cover topics from plastic pollution to acoustic profiling, sampling, drones, data tools. So we tried to do models for each of the module that we have delivered during the summer courses. And of course, if the students that attended there wanted to know a little bit more, they can still reinforce what they have learned and at least know the names of the people that were delivering the classes. So what's next? We believe that the Nautilus model is scalable and replicable because it's easy. You know, it's having people, it's having the availability of people to do it. And these models will ensure the legacy of the courses. And of course, our recommendations on our policy briefs that we have developed on the project call for a neat continued investment in training and open access resources to empower the next wave of ocean stewards. So as I said before, better than saying, it's better doing than saying. So I'll leave you with a sneak peek of what happened during these days of the summer course.
It's muted on YouTube.
It's
The
muted?
other screen. No. There. The big one.
The big one?
If you move them out over there, there is no.
Okay, I'll start again. No.
Maybe check the settings. But that if it's playing on the sound,
Sorry? Excuse me. I don't know. No, I think it's here, muted. No?
Again?
You know what it's not. Charles has fun music. Oh, I'll leave you with this. If you have any questions after, let me know.
Thank you, Sandra. So we move to our last Nautilus steps with Antonio Novellino from ETT in Italy. He's the data controller for Nautilus project, head of eModNet physics, right? And he will be presenting the open access data sharing part that, as also Sandra mentioned, is also connected.
Yeah. Thank you very much. Okay, so good afternoon for people that are online. So as we said, I mean, Nautilus is working quite a lot on many new sensors, and so they started producing a lot of data. And since the beginning, we were thinking about having an open data access, an open data project. So one step, just to define what is open science. Open science speaks about collaboration. So it's a process in which we try to share the knowledge, the expertise with colleagues in order to let them to reproduce or confirm what we are doing. And so it's important, it is a UNESCO recommendation, but it's important that you start thinking aside in that way since the beginning. Otherwise, it becomes complex to share and make benefit from the outcome of the project. Okay, so the basic principles that we need to keep in mind are to try and make, I mean, this knowledge early. We need to share it early as possible. We need to work on tools that enable other people to really follow the progresses that we're doing. We have to work on open access publication, for example. We have to have a clear research data management plan. That was quite important for this project because, as we said, we were developing a lot of new IPRs, and so that is sometimes could also seems to be conflicting with the open sharing of knowledge, but actually it is not. And so it's really important that we try and thinking and work it in order to have all this mindset really clear from the beginning. And on top of that, we somehow also anticipated some of the evolution of the Commission request on the data management for the research project, because Nautilus is a 2020, Horizon 2020 project, and somehow the concept of fairness, of data sharing was somehow recommended, but it was not, let's say, as committing as it is right now. And the fact that we were already planning, for example, having periodic reviews of the data management plan, also integrating some data management, data sharing, data evolution, workflows in different deliverables that we designed, was already in line, was already anticipating some of the, let's say, new trends and new recommendation from the Commission. We say that, okay, this is a long introduction to say that, I mean, the framework in which we were working, in which we are working, is quite complex. And in order to, as we are developing a lot of new tools that have a big potential. We have seen very nice summaries from the previous presentations. We really had to be committed in sharing all the potential, the data that we're producing with these new technologies with marine integrators. And in order to do that, what we did, since the beginning, again, we had the focus activities in order to identify which were the main stakeholders to which we were somehow aiming to provide some new information or some new data. Of course, at international level, we have many. We are going to see in a moment. But before going to that point, I would like to ask you to participate to this small survey. It's 3 questions because somehow it's very related to all the activities that we were doing and are doing in order to manage data, to make this data accessible. If you scan the QR code, then we can see if you have 3 questions. If I do, now how can I share the results?
On a web page?
Yes, it's a web page.
You have to stop sharing the presentation. Here, terminal. Stop sharing. And you can just move the Google page.
This one?
Oh, no. The other one. Right. That's the.
No,
Yeah.
there you are.
3 screens.
So if we do like that, okay. Oh, sorry. This. Yeah, okay. Okay, so the first question, as you can see, is when you need in situ data, which is the portal service that come to your mind first? And this is a quite important question that we were already addressing to ourselves when we designed all the data management procedures. Now we can see that Emonet is really central to this. We're also having other systems that somehow we know that are connected to Emonet. And this is quite important. It is very good. Oh, sorry, it's very difficult to work like that. Okay, the second question is, this is very interesting because we are also thinking about which is the feature that we are looking in a portal or in a service when we want to use data. And here we see that, I mean, there is a bit of jeopardization of, let's say, answers, but we can see that most of us are looking for feature to select and download data. We want maps, we want data, of course, so we need to access data. The open access to data is really, I mean, the key point that each of us is looking for. And this is also another very important thing. And then the last one is how we consume this data. And this is somehow it's interesting because I tested this kind of question with different audience, and according to the typology of the audience, you may have different flavors of the answers. But here we see that we have many scientists, of course. So we have a quite, dominance of tools like Python or R. But we also using quite a lot spreadsheet in order to put together results and show plots and stuff like that. So this is also quite important because besides designing a workflow that takes care about the data and make this data visible, then we also have to think about tools that can facilitate the downloading or the access to this data from the, let's say, a standard office man point of view. And this is quite important in the designing of the interfaces of the tools that we were developing in the project. And as already presented by the colleagues, we did quite a lot in this. For example, the application, the mobile application that is supporting citizen sign is already answering somehow to some of these requirements because it's really easy to be adopted and used. Okay, now I go back to the presentation. It's like, it should be like that. Okay, start here. Okay, yes. Okay. Now, going back to the point. We see that we have many tools that are collecting data all over the places. This is a very nice picture that I took from the Copernicus website. And some of the sensor and the system that we are developing are used back to back to some of these platforms, but are also complementing the capacity of collecting more data in some areas that these tools, this platform are not able to go. If we look at some of the science reports, we see that there is a lot of activity at the sea. This is the number of the days of ship at sea. And so it's impressive to think about how many days we are spending in order to collect data. And if you look at this, these are typical pictures that we see in many reports. We see we are improving quite a lot our capacity to record, to collect data. So in the past 20 years, there was a massive effort to keep collecting and sharing data. Okay, but how much of this data is really made available to users? How much of this data can we really download? Or how much is complete this data? This is another very nice picture that I stolen from one presentation from Flavio, because it's showing how important is some of the activities that we're doing, because we are missing we are missing a lot of data deep in the ocean. And again, Nautilus was addressing to complement this kind of information. So it's quite important. We have data, but although if there is a lot of data, it's not enough. So we need to do more. And as we said, how can we see which are our main stakeholders? IMONET, we said, it's one of the key stakeholders. IMONET is the European house for the in-situ data. So if we want to have data, if we are producing data, we want that this data is available, is accessible from IMONET. That is also sharing with Copernicus, that is the other European program for the observation and monitoring. But if we share data with IMONET, then we know that this data is made by, we make value of this data. It is accessible, it can be consumed. So, of course, we are targeting IMONET physics, also because I'm involved in that, so I know what we're doing. But IMONET physics is in charge for collecting most of the data that Nautilus was going to collect by means of the sensor that has been developed. Here we have, again, a nice picture of the amount of data of the platform that is already included in IMONET physics. But again, if we want data, if we do a deeper analysis and we see how many recording days we have in a pixel, in a grid cell, where this is, days of recordings from the 1st January 2024 to end of December 2024, we see that we have a lot of gaps. We have a lot of gaps. So it is important to share data. It is important to think about an open data access and sharing infrastructure that can immediately connect new data into these systems, into these integrators. And so what we did, because of course, by having the data, we can answer to many of the society question and benefit that we are addressing with Nautilus. And in fact, if we go back to one of, the design that we wrote in Nautilus, we see how we were mapping all this information into a sort of workflow of from the sensor to the, let's say, target. But to do this, of course, we need to have a good data management. And so in Nautilus, what we did was to design a data management infrastructure that was able to manage both the validation of new sensor data, because of course we are developing sensors, so we need first to validate this data, to qualify this data. And so we have, we designed this inner loop, the red one, the red circle, in which as soon as a new sensor, a new platform was becoming available, together, we were checking the data, the consistency of the data. We were adding some key metadata in order to be able to share as soon as possible this data into the marine integrators. Then we were deploying this workflow. And then as soon as the new sensor came to be operational, this data was directly flowing into the system. And the system is made of tools that has been recommended by Imonet or from Goose in order to be able and share immediately in a fair way all the data and information that we were collecting. For example, we are using AirDAP, that is a platform, is a system that implements a sort of middleware between the data and the user, and helps also the data formatting or facilitate the way we can add metadata on top of that. And this was very powerful because by deploying an AirDAP system on top of the Nautilus data, we were both serving the Nautilus portal, data portal, so we were facilitating the work of our colleagues that were developing this nice interface, but at the same time, we were implementing a key node for offering this data towards Imonet or Copernicus and other potential stakeholders of the data. At the same time, this was also very useful in order to implement some operational data flow, and we tested it for the Adriatic fleet, fishing fleets, as well as for the sea mammals that were collecting data here in the Azores. So it was very important to set up all these open ideas. And together while doing this, we were also able to identify some limitation of the standards that were used at the time. For example, one contribution to Nautilus, for example, to improve the metadata of Imonet was to identify that some of the characteristics of the sensor cannot be included in the global attributes, of course, of the platform, because they are sensor specific. So we had to think about how to reorganize the management of the metadata at let's say, a more specific level. And this is also a good contribution of the project towards more other international committees, because now they are speaking about this problem, and now we are adopting this kind of information, because with the sensor, it comes the uncertainty, and uncertainty is one of key let's say, information that we need to know in order to implement added value products when we are grouping together many data. And if you have a platform like Imonet that is offering a lot of data, you need to offer also this kind of information to enable the user to filter out the specific information that he can pull together in order to answer a scientific question. So we can see that there were a lot of activity also in the data management, and also in this we were anticipating. But okay, so what this is also quite interesting, because I spotted out that most of the scientists are really keen to implement a data management plan, but they do at the beginning of the project. And then when the project is finishing, they are somehow a bit disconnected to what they were promising. So what's the status of Nautilus? Oh, we know we were doing well. But this is just to show some, very nice results that we were able to put together. So as I said, we implemented an infrastructure that is serving both the Nautilus internal services, so the data portal, the processing pipelines that some of the colleagues have put together, but it's also offering data to marine infrastructure integrators. We have a system. This is somehow visible only to, let's say, more techie people, because the ambition of Nautilus was also to offer different views and different flavors to different people. Sandra made a very nice presentation about the personas that we were targeting. And so if you want to check which data is available, which is also the status, the readiness level of this data, because we were also collecting and organizing also the test data in order to be sure that we were able to fully cover all the full data management pipeline. We can go to our Nautilus AirDAP server and we can list all the data. So if we interact with this system, of course, then we can see the values, the collected values. So it's already open, it's already shareable. We can see also picture of the data. But what is more interesting, that these data are already integrated in Emonet. For example, if you go to the Emonet page and then you filter by Nautilus as a project, then you have many data that are already there or are continuously flowing. Here I just reported a couple of examples from the fishing vessels in Ancona. And by the way, it's also nice to see the differences that we have in Emonet and in the web portal of Nautilus, because in Emonet we are showing all the packages as one single point, because it's also easier to show the place. While in the Nautilus data portal, we can see all the different location of each single sample that has been done. But the final result is that we are offering the transact that has been collected there, as well as the data from the colleagues from the Azores. When they did the different trials with the mantas, we were able to collect some data in an area that were not covered yet from other platforms. And now, I mean, the database is much more complete. Or, for example, it's also important to say that some of the sensors have been deployed into already running infrastructure. This is the example from Greece. And in that specific platform, we were able, thanks to the Nautilus project, to add more sensors. And so the data that is already flowing into Emonet and Copernicus is now enriched with more sensors and more variables. And so we are better contributing to the different societal challenges that has been addressed since the beginning of the project. But this is not the last things, because we also spoke about the citizen science activities that we were doing. As already presented, we designed the mobile application in a way that it was already mapping the information according to the requirements of the marine beach litter registry or product. And so these data are already ready to be consumed by Emonet, for example. But as it doesn't exist an operational pipeline to collect this data directly from the application into the system, we pass it by the modern ingestion. And so if we look, for example, at the modern ingestion webpage, we can see all the submission that has been produced also from Nautilus. And so these are also clear KPIs that we can offer when we are speaking about the monitoring of the project. And so, as I said, how we were doing, I mean, when we ask how are we doing with the fairness or open data management in this project, we are doing well. I can tell you we are doing very well. So just to conclude, I mean, we can say that, of course, thanks to Nautilus, we have now more chemical, biological, and deep ocean physics variable available. We have demonstrated that it is possible to collect data with cost-effective sensor and platforms. And so we need to keep pushing this. I mean, we have already seen very good flyers and a way to present and propose these tools. We have a better resolution because according to the topology of sensor or platform, we were able to reach deeper sea or higher resolution, both in terms of time scale or geographical scale. We were able to integrate, I mean, this data with already running operational platforms. And so somehow we can say that thanks to Nautilus, we are also contributing to expanding the European capacity to collect data. And of course, it's also important that we were able also to close the loop between the science and the people, and all the citizen and science activities that we saw before are fundamental to this, because it makes a better awareness of how important it is to be all on the same side of the wall, I would say. And so, again, if we have to say which is the, let's say, the outcome on Nautilus, there are many outcomes, and from the data point of view, we were proceeding very, very well. Thank you so much.
Thank you, Antonio. Yes, as we saw, the four various aspects and the data that are underlying all the various connected the presentation that we saw before, they represent a nice underlying connection between all the previous presentations. Okay, so now we should be starting our panel. Let me simply share the screen. Okay. I think all the finalists are connected and they should be at the right for sharing and presenting and opening their microphone. We wanted this panel to address some of the activities of these panelists, and we asked them to show also the connection with what we were doing within the Nautilus activities. So we have a little bit of delay, so I would start straightly. We will start one by one. So first, I'll start with Connor Delaney. Connor, are you there?
Yeah, I'm here. Can you hear me?
Hello. So Connor Delaney is the technical coordinator of the European Maritime Observation Data Network, EMODNET, key marine data sharing initiatives, as also Antonio has shown before. He has over 25 years of experience in ICT, environmental science, and big data. Connor has worked across research and industry. He holds a PhD in physics and a master in environmental science with extensive expertise in marine atmospheric and Earth observation data system. And let's say that its main focus in this panel will be about EMODNET and Edito, another platform. Connor, I leave the floor to you. You can share your presentation.
Okay, hello everybody. You see my presentation?
Perfect.
Excellent.
Yeah.
It's not very long, so don't get too distressed. I just want to give an overview of EMODNET, which many of you are aware of, which Antonio is the head of EMODNET Physics. It was great to hear his presentation there. EMODNET is a service run by DG Mare for the sharing of in situ observations in the marine regions around Europe, from the seabed up to the top of the water column, including what's on the top top of the water, like shipping and offshore wind farms and stuff for human activities. So it's filling in a gap that we don't have in Europe. We don't have a unified pan-European marine data service in terms of an institution. So the Commission funds EMODNET to deliver the unified data products for Europe. So we pivoted in 2023. For those of you who may remember, before 2023, there were 7 separate EMODNET portals, one per thematic. I know we have bathymetry, seabed habitats, physics, biology, chemistry, geology, human activities, and I think that's it. But now that we unified them all into one service, which became operational and is run on DG Mare, on the European Commission domain. So it's actually now an operational service of the Commission. Plus, we made all the data and data products available through that service. So you used to have to go to all the separate portals to find the data you were looking for and to download it. Now it's all through the one service, through the map viewer and through the catalog and through our own AirDAP server, as Antonio was referring to these technologies in his presentation. And the goal here is to make it easier for people to find the data they're looking for doing work and research in the marine areas. Like that, there was a great illustration there from Antonio on looking for gaps where observations needed to take place. If it wasn't for unified data sets, it'd be much harder to find those gaps. So, and also the Commission was very concerned that the money that's been used to make observations and produce data products was producing high-value data products that were very hard to get access to. And at the end of the day, all citizens should have access to this data because it's funded by public funds and therefore it's open data. And one of our key, just to give you a couple of overviews, one of our key products, for example, is the unified digital terrain model of the seabeds of Europe. We're the only, if it wasn't for EMODnet, there wouldn't be one. So we have a high resolution digital terrain model of Europe, and then we have much higher resolution, smaller areas around Europe for getting much higher resolution digital terrain of the seabed. That's all downloadable directly from EMODnet, from the map viewer. No logins, nothing. You just download it directly in a format that you can use. We also do a lot of work and support for the Marine Spatial Planning Directive, or the Marine Framework Directive. For example, we mentioned litter earlier on, marine litter, and that's brought in through the EMODnet chemistry, and it's also shared out for the Marine Strategy Framework Directive as part of the ongoing work from EEA. We also look at other things like planning, sort of non-scientific area. This is a policy area where we're taking the maritime spatial plans from each of the member states and we're unifying them into a GIS layer on the map viewer. And then you can go into the map viewer, see how each of the member states have designated the activities in their national zones, and also you have direct links to the plans for each of the member states. These are things that would not exist unless we actually spent the effort and time to do it, because there's no obligation on member states to produce a plan for other member states. So we have to work together on this to do this. So at the moment we're waiting for France. We should have the France one soon, and Italy have already committed to producing their one as well. And on top of this, the fact that we produce these unified data products, we've already learned that member states are using these unified data products to help them in their planning for both their scientific programs and their policy and policy analysis to augment the information they already have on their own marine waters with the data that with data that exists outside of their boundaries, so that they have a better understanding of what decisions need to be made. And we also make all this openly available. This is extremely important, and it's extremely important for all projects going forward, especially when I see great work here with Nautilus. There's no point collecting data if you're going to hide it away. It's just a waste of time, a waste of people's money. There's so much innovation going on, especially with the development of the tools that people now use for doing data processing. People come along and innovate with your data, to do things which you never thought was possible, because you're not exposed to the type of technologies that have been developed. So therefore, if you lock your data away, you're never going to reap those benefits. Also, you have an obligation, because the data is funded by public funds, to make the data available to others. So we do everything we do in EMODnet. We make sure that all the services, web services we use, all the data services we use are the same ones that are available to the public. So what you see in the map viewer, you can do yourself using our background server technologies. What Antonio touched on there, we use a very limited set of technologies, all open source technologies. And we're looking ahead now, just on the last slide. EMODnet now and Copernicus Marine both work very closely together now. EMODnet is from DG Mare, Copernicus Marine from DG DEFIS. Together we've built a data lake. And if your data comes into EMODnet, it will automatically go into the data lake. And Copernicus Marine have put their ocean model data and Earth observation, which is big data, on this lake. And EMODnet, while it might seem big, compared to that is small data, but it's also there. And the idea here is that people can log in using the new tools that are available, the open source tools in Python and R, and create a notebook and start processing data immediately to produce new products. So we're really trying to make sure that there's a wide range of avenues for people to use to get access to data to help drive innovation going forward. So that's it. Thank you very much for having me here.
Thank you, Connor. Yeah, so we started with a presentation from Connor that, it was very linked with what Antonio presented last. So it's a very good connection, and I think it's in all our panel we'll see something that it's from an external point of view with respect, for instance, with the room that is filled with Nautilus participants also, and can be very interesting for many of them. We're now moving to another couple of panelists, which are presenting activities that are currently going on, that are kind of complementary each other. We start with Enrique Alvarez. Enrique, are you there? I saw
I'm
you
here.
before.
Do you hear me?
Yeah. Hello.
Good.
Hello. Okay, Enrique is the technical coordinator of the DCC Decade Collaborative Center for Ocean Prediction. It is hosted by Mercator Ocean International. He's a physical oceanographer and experienced forecaster. He previously led the operational oceanography division at Puerto del Estado, managing an integrated observing and forecasting network, supporting diverse socioeconomic sectors. And so, Enrique, the floor is yours. Enrique is presenting about Ocean Prediction DCC. Please.
Thank you. I'm sharing my screen now. Sorry, I have to switch this. I hope it's okay now.
Yeah, perfect.
Good, thank you. So I'm going to briefly explain what were we trying to achieve with the Ocean Prediction DCC, the Decade Collaborative Center, and what we are trying to achieve. As you can see, I'm already advancing something because I'm saying our motto, which is connecting the world around ocean forecasting. So this is in one slide what we pretend to do with the Ocean Prediction DCC. Please remember we are in the framework of the UN Ocean Decade. So this is about international cooperation. This is about collaboration and about building together a new scenario for ocean forecasting. On the left is the ocean forecasting that we have now, that we have at the beginning of the decade. And what we see is that we have very good systems. We are proud of the forecast systems that we have, things like Copernicus that we have been building for the last 20 years. But we have to admit that those systems are difficult to integrate, difficult to operate, difficult to implement, and they are somehow technically disconnected. We don't have a good network, a good human network around it, and we don't have a good technical network around it. Therefore, for those institutions that are technologically less advanced, it is quite difficult to build and operate one of these systems. So what we're trying to achieve altogether in this analogy of the Ocean Prediction DCC vessel that you see on the slide, having as captain the UN Ocean Decade and as crew all the community that we are building around the Ocean Prediction, is to change to a different scenario where we will have more systems, more robust one, using common tools, using common interoperability assets, all of them sharing knowledge and sharing tools to make the data, the results interoperable and more easy to operate and implement. So we will have more of them on those countries and those institutions that are technologically less advanced. Therefore, we will be able to further exploit the socioeconomic benefits of these systems. So this is in a single slide what the very ambitious objectives we want to contribute to. So how we are doing this today, this is how the DCC program looks today. We have, let's say, on the left, a main block activity, which has a component, a technical component, a technical framework, where we are building several assets that are very important for doing this transformation. I will explain a little bit about these assets on my following slides, the architecture guide, the operational readiness level, and so on. Then we are building our community around regional teams. What we have done is thinking that we cannot be influential in every part of the world from Toulouse. So what we have built are regional teams around the globe based on other existing initiatives. So we try not to reinvent the wheel. So when there was some group that could have this role, we link with them in order to represent our ocean prediction DCC community. And then we have some two new projects that we got launched this year with European funds to, let's say, spearhead, to be the leading edge of the developments we are doing. This is going to be where we are testing all these ideas, all these tools that we are actually building at this moment. One is the so-called OPERA project. OPERA stands for Ocean Prediction Enhancement for the Regions of Africa. And another one is Ocean Prediction for Costa Rica. And these two are going to provide us with the resources and with the ground field to test all the concepts that we are building in the Ocean Prediction DCC program today. So talking a little bit about these regional teams, those are the leaders of the regional teams, the different institutions that are in the different areas of the world leading our effort in these regions. But if we put this together with all those institutions that are forming the steering teams of these regional teams, you see that we have a fantastic network worldwide that is in place, helping us to implement all these technical developments that we are creating, and helping us to spread the voice, to create a communication, to create this human community around ocean forecasting, to support each other in the building of the systems. From the more technical point of view, there are for sure many ways to build this idea, many ways to think on how to promote ocean forecasting worldwide. Well, we have our way, and this way is summarized in this slide. And what we're doing this through a, let's say, virtuous loop that you can see on the right. And we have in the core of this virtuous loop the community that we have built around our regional teams. So starting at, for example, in the upper part, because this is a loop and we can start at any place, we can start by saying that in order to build a forecasting system, we need the knowledge. Then we need to understand how to build the system. Then we need to understand how to operate it and to upgrade it. And finally, we need to integrate these things into digital twins, such as the one that was mentioned before by Connor on the European DTO. So for one of these steps, what we're doing is to creating the assets, to creating the tools to promote the proper implementation of these steps by our community, by the Ocean Prediction DCC community. And I will explain all these elements in my following slides, the tools, the architecture guide, etc. But I want to highlight that we are not doing this alone. We are doing this in close collaboration, first of all, with the two DCOs of data sharing and ocean observing, and then with many decade programs such as 4C, Best Practices, DITO, Cost Predict, or GEMS Ocean. So, and others more, which are not on the slide. So we are certainly working together in the decade framework to try to exploit all these assets that we are building through this virtuous loop. So let's start a little bit. Yes, I'll give you some flash because I cannot go into the detail of this. If we start with the community, I highlight here, for example, the Ocean Prediction DCC Atlas of Ocean Forecasting Systems. We have in this atlas now described 180 systems in high level of detail. It's really the operator of these systems, the one that are describing everything. So this is a metadata atlas that describe the actual status of ocean forecasting around the globe. If we go to for example, to this other part of the loop, which is the development of ocean forecasting, we have published last year the so-called Ocean Prediction DCC Architecture Guide, which is really a wiring diagram, a set of wiring diagrams, teaching people how to properly build an ocean forecasting system from scratch. So it tells you how to do in an elegant way all the wiring, all the what is needed to build a robust and properly elegant built ocean forecasting system from inside. If we go also in this part, I would like to highlight, because it's linked with your previous presentation and all the interoperability stuff, the work that we are doing now. This is part of continuation of the architecture guide on the data standards. So we are working with other partners, trying to properly create a specification about data standards for storing ocean forecasting data. Moving to the next one is a step of the loop is how to operate and upgrade a system. For this one, we have published last year the so-called operational readiness level. The operational readiness level is really a series of best practices that teach people how to properly operate those systems. And together with this collection of best practices that are in three categories: production, validation, and product dissemination, you have a test that is helping you to identify what are you doing correctly and what are you doing not that correctly and where you need some improvement. So basically, you can play the game of computing your operational readiness level to learn how you are doing with respect to the operation of your system, which is something very important for those institutions running these systems. Finally, about integration, we are working together, as I was mentioning, Ocean Observing DCO, Data Sharing DCO, and Ocean Prediction DCC. We are working together with other Decade actions to build a Decade network, a Decade technological framework to really promote interoperability, a digital ecosystem, a Decade digital ecosystem to promote interoperability, and working with, as I said on the slide, one ocean, one digital ecosystem as a result of the Decade. So as conclusions, Ocean Prediction DCC is working in close collaboration with Decade partners to promote ocean forecasting and its application during the Decade. We have organized our community, our active community around the regional teams, and the first results of all this effort are already visible, and you can download these from the DCC webpage. The architecture guide, the operational readiness level, the Atlas forum, and more ideas that are like the work on data standards that will come on the following months and years. And I suggest to you, if you're interested in this world of ocean prediction, to register at our webpage and be part of our community. Join us by registering into our webpage. You will have access to many things, and you will have access to, for example, to the regular news and participation in the forum and so on. So this is it. Thank you very much. I'm ready to discuss all these things. Thank you very much.
Thank you, Enrique. So we started to see, let's say, the wider frame instead of, the whole world of data that we have, and we hope that we contributed with our Nautilus project. And connected with your presentation, I would follow straight forward to Viviana Piermattei, who will be presenting about Coast Predict. Hello, Viviana. Okay, Viviana is a scientist at the Euro-Mediterranean Center on Climate Change, CMCC, where she coordinates the Advanced Observing System Research Unit. Her work focuses on developing innovative sensor and platform for coastal monitoring, advancing low-cost marine technologies, and promoting citizen science within Global Coastal Division. So, again, strong links with all the Nautilus activities and what we've seen till now. Viviana, the floor is yours.
You can see my screen? Can you hear me?
Yeah, we can see. Maybe the volume is a bit low from your side.
Can you hear me?
Yeah, we can hear you.
Okay, thank you. So, hello, I'm Viviana from CMCC, and today I will present, as said before, the Coast Predict program. The Cost Predict program is one of the 3 Goose Ocean Decade program that is chaired by Nadia Pinardi, who also is the director of the DCCTR, that is the Decade Collaborative Center on Resilience. And Cost Predict has a vision that is the predicted global cost solution from events to climate. And to do this, it will require an upgrade to a fit-for-purpose oceanographic information infrastructure that can integrate the latest technologies and methods both for coastal ocean observation and prediction. So the main objective of Cost Predict is to co-design and implement an integrated coastal ocean observing and prediction system that can support the coastal resilience. And this vision and this objective will be demonstrated initially by through the pilot sites, where the Cost Predict program will implement a relocatable system that will be developed and tested to respond to coastal community and stakeholder needs. And the benefit of doing this will be for sure a system that predict into the coast both for short-term early warning system and long-term projection. So to do this, it was established a global coast network through surveys, and this survey include 130 pilots that were collected in over 65 countries all over the world. And the Global Coast project represents the framework for the implementation of the Cost Predict program goals. So this network has been now formalized through the establishment of the Global Coast Network Memorandum of Understanding that now was signed by almost 40 institutions. So the Global Coast will create a replicable solutions, standards and applications to enhance the coastal resilience for both natural and built environments. And the main goals will be the overcome of technical barriers to connect the work globally, enable the public-private collaboration, create a replicable solution, and increase the data collection and sharing. So the Cost Predict program created also a menu of solutions, a key document that represent a roadmap for building capacity for coastal observing, forecasting, and resilience. And it outlines the existing good practices and prototypes for coastal observing, modeling, decision support services, training, and stakeholder engagement. So it represents a formative reference for the pilot sites to implement the integrated Cost Predict system. So it will be, it is under the review, and it will be submitted in the summer 2025. We have spoken about the low cost and cost-effective solution and the citizen science. So it's very important the engagement of coastal communities to make available this kind of technologies, because this engagement will be facilitated by the use of affordable technologies that could be also used by citizen science initiatives. So the Cost Predict program involves a lot of initiatives and networks that can facilitate this through the also development of low-cost sensor and the collection of data through this kind of initiatives. So this is like a slide of a list of the potential services that could be developed through the Cost Predict program and the implementing program with Global Coast that come from the extreme events and early warning, and also support the coastal management but also the management of marine protected areas and also the planning of, for example, marine renewable energy. So a lot of application could be implemented through the cost predict implementation. But since my research focuses on the development of low-cost sensor, development, realization, and test of low-cost sensors and platforms, I take advantage of this opportunity also because cost predict is supported and push to involve the community and also the technology providers to have many low-cost sensors or cost-effective sensor to acquire new data. I want to present the CSMAC1, the Marine Citizen Science Data Horizon project. That is a new Horizon project that will start in June 2025 that has the aim to build a network that brings together the marine citizen science actors with a focus on data flows. So since all the presentations speak about the fair data flows, the fair data mainly, and this project will try to, through also demonstration pilots that will be distributed in the European seas, North Seas, Atlantic waters, and Mediterranean Sea, different pilots will try to create an interaction between the citizen science communities like citizen science initiative, but also technology providers, data management experts, and researchers, trying to put together all the data coming from the citizen science initiatives and flowing through the European platform. So also EMONNet is part of this project. So it will be possible to bring all the citizen science data on the European EMONNet platform. And this will be very important because some of the application will be related also to the demonstration of these capacities, also on application like on the digital twin, but also numerical modeling that will be able to use a lot of many data that will be provided by citizen science initiatives. And so thank you for this opportunity, and I am open also for questions. Thank you.
Thank you, Viviana. That was very interesting because besides the cost predict initiatives, which is complementary to ocean predict that we saw before, as we discussed when we agreed via mail, it's also important to focus on this new project because it brings a very important focus about citizen science data that it's very important also in Nautilus point of view, let's say. Thank you. Okay, so we move now to the next panelist. It's Patricia Lopez Garcia. Hello, Patricia. Patricia is a sensor science delivery lead at the National Oceanographic Centre in the UK. She managed Tech Oceans project and played a key role in sensor development, system trials, and coordination efforts. Patricia's expertise lies in delivering cutting-edge marine technology solutions within multidisciplinary ocean engineering projects. Patricia is here today on a slightly different frame with respect to the presentation that we saw before, because she managed Tech Oceans, and Tech Oceans is let's say twin project with respect to Nautilus. Tech Ocean finished just some time ago, but they were from the same call, and so we had some kind of complementarities since the foundations, I would say. Patricia, the floor is yours.
Wait. Can you see the screen?
Yeah, perfect.
So hello everybody, my name is Patricia. First of all, I would like to thank the project coordinator Gabriele, the PME office, and all the partners for the invitation. It's been truly exciting. It's been truly exciting to hear all about the fantastic success of our sister project. And then, so like Gabriele mentioned, I'm going to talk about the Ocean project, which is the technology for ocean sensing. The main objective of this project was to develop a range of innovative technologies and methods for deep sea sensing, sample collection, and onboard analysis, and artificial intelligence-driven image processing and transmission, because we want to improve the ocean observation. The project has 13 partners all around Europe, as you can see in the slides. Because it's a lump sum like Nautilus, so the project had a kind of different distribution, and then with three main themes, technology themes. The theme one, which was focusing genomics technology, the main objective was detecting and quantifying biology via the nucleic acid, DNA or RNA, using robotic samplers and in situ sensors. The theme two was the imaging and optics, which main object was automating data extraction from images. Then we have a theme three for the microsensors, which develop in situ high performance water analysis. They have three different technologies I will tell you later. Then the theme four was the cross-cutting and testing. The theme five, dissemination engagement, and theme six was the management. Oceans has successfully developed advanced sensor technologies for marine monitoring with applications and policy impacts in a wide range of aquatic environment. In this table, you can see like a summary of what it was developed. And when you have the technology, the TRL that it was reached by the end of the project, like Gabriele said, the project finished in September. And there's some of the application for this technology. So we have a microcytometer, who is able to measure microalgae, phytoplankton, and microplastics. We have the microstab technology, which is a primary productivity sensor. We improved the UVP6 when working with image for pelagic microparticles and species. We have nucleic acid sensors, which measure micro and large organism abundance and genomic function through DNA. Then we have samplers. We have the DNA, which is now called Roxy. It's already commercialized sampler. We also had the microplastic sampler who reached TRL6. We have also dual chemical sensors. In our case, was for nitrate phosphorus, silicate phosphorus, and total alkalinity DIC. There were three different ones. We have antibody-based sensors which are used to detect organic contaminants and algal toxins. And we work in methods of data compression, information and encoding and transmission, and then in methods of training artificial intelligence and machine learning. And in our case, we kind of focus a lot in doing test in two main locations. We have, of course, all the tests to kind of test the sensor while we are advancing the TRL. So by the end of the project, we have these two main deployments. We have one was in the Atlantic mission, was in Gran Canaria, with organized around in the Plocan facilities with our partner, which was the partner of the project too. We brought 4 different technologies that where our sensors and samplers were integrating in those. And then the main objective was to being able to detect different biochemistry in the area. And the area was very relevant because it's already known that the south of the island is very important for mesoscale system like EDIs. So the first one was an Autonaut. We integrate a microstab technology. This one only stays around the east of the island due to some integration problems, but it managed to have a successful mechanical integration. Then we have in the red, it's quite small. I don't know if you can see. The south of the island, we deploy a sea glider who was carrying a lab on ship. This is a wet chemical sensor for nitrite, together with a phytoplankton primary productivity, the microstab that was integrated on top of the glider. And you can see like we are still processing the data, but you can see like a preliminary data from the nitrate from the transect that was in the south. We have one AutoSAP that was the AutoSAP from NOC is developed here NOC, so it was carrying quite a few technologies. You can see here on the right the photo before deployment where we were checking the sensors on the front, which are the LOC sensors, and you can see with the in yellow and blue the reagent bags. So in the bottom, you can see the two main missions was one to the east of the island, which was the sensor testing, what we call it the sensor testing, and then the AutoSAP went to the side of the island and did the loop that you can see here. The color means the depth that it was reached by each dive. Again, the data is still being processing because they're quite a lot. And then the fourth technology was another AutoSAP, and in this case, it was carrying what is called the biocam. The biocam is a system, it's a camera system, and this system works in the east of the island. So the main objective of biocam was to prove that the system is intelligent enough to transmit a very low bandwidth information. And so you can see in the east, it was doing like a few transects and classifying in this case was the main objective was checking the classification of the bottom of the sea. Sorry about I don't know very well the technical words, but so that was the main. How I mentioned, there were two big deployments. The second was in Naples. It's a monitoring station at the Cinestologica Anton de Naples. CSNN is another partner of the project. And in this case, we managed to deploy the cytometer, the deep option of the cytometer. It was the first profile. We also have some other technology like the staff, the primary productivity, working alongside with the here you can see this is the staff, and this is the Roxy, this is the cartridge to collect DNA, it's a sampler. And yeah, so I was asked to talk about synergy activities with Nautilus. I have to say that since the beginning we have been having meetings. We had meetings is the project manager office with the coordinators. We organize meetings within different things and different researchers trying to find things that we could do together. It was quite difficult sometimes because of the project have their own task and places that we need to deliverables we need to finish, but I think we can say that we managed to do a very good important things. We also join every month the All Atlantic group, so we were always every month in contact. And then from there, we managed to organize during one of the technology showcases here, organized here at NOC. We organized the European stand, where we joined also George's project joined us. We also joined a stand during the Ocean Decade Conference in Barcelona. Gabriele, as Nautilus coordinator, joined our policy event as a panelist and expert. We have partners from our group, from our project, from IMBB specifically, who joined the Nautilus Summer School in 2024 to talk about the Tech Ocean project. We also have two early career researchers representatives from Nautilus who joined the Tech Ocean Marine Technology training that was happened in Plocan in 2024. So about the project legacy, I wanted to discuss here just, for example, in Ocean Best Practice, we have a repository where we have been adding not only some of the deliverables, but some of the sensor manual templates and also sensor manuals. In our case, the sensor manual templates is for sensor developer. We wanted to make sure that we can produce very good quality data from the sensors. So it was very important to take into account the metrology. So we tried to do that, including the last ISO that have been published for this case. We also have a Zenodo repository. We still have a web page, which is you can find a lot of information. The main thing that you can find is our key achievement booklet. We have some data. As I mentioned before, we are still processing some data, but it's already some data available in some databases like BODC, and the image also there in another open database. Some of the technology is already included in current projects like AkeBiosense, George Tricuso, and Marco Polo. There is also a project for the biocam called Oasis project, and then there are two projects that have been recently awarded from the Fusion Marine Research Infrastructure. This is a UK initiative, and I know that there are a few partners that from a group that are very active at the moment, looking for funds, trying to join calls for the next European Horizon Europe calls. Some of them already mentioned that they are a part of the consortia, and also they are also said that they are trying to get apply for their own country's funds or national funds. And then as a project legacy, we have two technologies that are already commercialized. This is the Roxy. This is the DNA sampler. It's commercialized by McLean. The microstaff is by the Chelsea Technology Company. We know that we were informed that BioCam is in the process of commercialization. And then we have a patent file for the flexible technology. So that's all. Thank you very much. And if you can always contact us if you have any questions, just let me know, please. Yes. I hope I wasn't too long. Thank you.
Thank you, Patricia, and thanks also for recapping the many joint activities and events we participated, because I mean it's useful to show that. I mean, at the beginning it was a bit tricky, but then we managed to set up many, and I mean through your presentation I could also see many more similarities also in the pathway that we've been through with the technologies and all the efforts that we've been put and the results, the outcome. So it's also useful to see and to show another similar point of view to all the people. Thank you, Patrick. Okay, now we are moving to the next two presentations, which are in-person presentations. The first one will be from Rui Martins, who is the Regional Director for Maritime Policies for the Government of the Azores. He has a background in pharmacy and healthcare management. He has leadership roles in the Regional Health Service and served 2 terms in the Azorean Legislative Assembly, contributing to committees on environment, economy, and EU funding oversight. He remains active in civic and community development, and today he is here representing the Ocean IDS project, who is, let's say, the latest of Nautilus synergy that we are getting in touch, being it a recent project. I don't know if it's already open. No, I can open it. Which one is the Ocean ID? Ocean ID. Okay. Okay.
Yeah. Okay.
Please,
So
you know better than me.
Let me think. Well, thank you, Gabrielle, and thank you for the invitation, and obviously all the partners, and for organizing this final meeting here in the Azores, and well, and this allowing us also to share this project, which is Ocean IDS, and so we are the regional directorate is a end beneficiary, so to speak, end user. We are partners of the project. This is an Horizon project. Oh, okay. Okay. So maybe hold on. It has to be here, right? Here, maybe it works like that.
On this screen. Yeah.
It's okay.
The one,
This-
below.
This one.
This one.
Yes, okay. Yeah, okay, there we are. Thank you. Okay, so this is this is the project, and it is an Horizon project, it started in December 2023, and it will last probably will end by the late summer of 2026. These are the consortium itself, as you know, it's a big team from Finland and also Spain and also Portugal, France. So it is a big consortium, and the end users actually lay also in all these countries, and in the government of the Azores is actually one of the end users of this platform that is being created. So the directorate itself, I was gonna take this out because there's no need for it. I'm sorry. The directorate itself. So I was gonna talk about our. Wanted to take the sound off. Oh, maybe I have to go over there. So our aim, we support the development of regional policies aimed at the economic and environmental valorization of the Azores maritime space. We also promote the knowledge of the maritime environment. We are responsible to enforce the maritime strategy framework directive. We also regulate the maritime activities. That has to do everything that has to do with maritime spatial planning, and also implement the necessary measures to preserve the ocean's good environmental status, which is the MSFD. So that's our work. We do a lot of field work also, and we collaborate. We have many collaborations with local scientists, the Oceanus team, and the university, also IMAR. They're there also to support decision making and policy making. And so the Ocean IDs aims, it's basically build a user-driven application tool that in order to achieve a more resilient and inclusive systemic pathway to the blue economy in coastal regions. That's why it is spread a bit on coastal regions throughout Europe, from the north all the way down here to the Azores. The aim is to create a single access window platform that provide climate-informed maritime spatial planning. Obviously, so the idea is to collect, harmonize, and curate existing climate data services, making data accessible and reusable, which is a bit also the same objective that we've heard before. So we would like to promote inclusive and deliberative government through meaningful engagement and dialogue between citizens and stakeholders to accelerate transformative changes towards climate resilience. So the project itself has 6 work packages. So the stakeholder identification and engagement was the second one. Then the core technology modules for data and service federation and curation. Also the user-driven tools, applications, and development. And then demonstration of the Ocean ID's tools and applications. Obviously, we also aim to disseminate the information and make it more useful for the community. So these are the diverse climate zones that were selected. There's 4 of them, and they go from the north, the Nordic climate, and then come down to the Eastern continental climate, also the oceanic climate, which that includes the Azores, and then the Mediterranean climate area. So these were the ones that were considered in this project. The idea was to create a diverse portfolio of case studies that could effectively capture the aspects of climate change impacts across the various regions. So the key considerations and criteria used in the selection process were the geographic distribution and also diverse characteristics and climate zones. Hence, the 7 pilot sites for this project are the region of Bretagne, the Azores, Malaga City, and Malaga Port, Bremen, coastal Finland, Greek islands, and Crete region. And then, so here the Atlantic pilot sites, even though Bremen is on the North Sea, but it is also, according to the division that we made, these Atlantic pilot sites. So it's the region of Bretagne and the Azores. So what we want to assess, it's the climate change risks and natural hazards. Obviously, so it's the sea level rise, the map and assess the flooding, the forecast and map winds, climate change risks, increasing number of marine dead zones, the multiple climate hazards, the risk of biodiversity loss, and also post-event earthquakes assessment, which for us it's also important. So in the Azores, the 3 ports that were defined are the port of Ponta Delgada in São Miguel, and the port of Horta here in Faial, and in Praia da Vitória, which is Terceira Island. So the idea at first was to have 1 port in each of the groups of the archipelago, but since the port of Flores is actually due to an hurricane got devastated, and so is now is now being rebuilt. So that's why it wasn't elected as a port for this project. So these 3 are the ones that were selected. So the idea of the platform is to have Earth observation data visualization. So in order to have risk identification and then decision support system for the actions needed to mitigate. So these are the results for mitigation measures together with the recommendations. So as you can see, this is a bit like an insight of the product that is being under development. And also here we got a video of the platform and that's being created. And this example is for the Heraklion port. As you can see, it's the Earth observation kind of platform, and you can actually dig in, and then there's multiple aspects on the coastal change that you can assess. And so the idea is actually part of the work is to define or to gather information on the existing structures that we have in all of these ports, and then with all the engineering data that we have, also when it was built, and that will allow us also to see the impacts of on modulation. When you change whatever adverse event you have, you can see the areas that will be the most impacted. And so it is, I think it is important not only to kind of mitigate the risks for the current infrastructures, but it is also very helpful in defining new investments and when defining new areas of activity in ports, and obviously in cities also, but here we're focused on ports. So this is a bit of the, an insight of the platform and that's being created. I don't know, maybe we're a bit short of time, so I'll just skip. Yeah, well, you can see there's the multiple factors that you can then you can actually insert, and there's the history, obviously, that it was charged, in meteorological characteristics and the data and whatever data we have from the past, and then that allows us obviously to modulate for the next 10, 15, 20 and more years. So this is pretty much this is already for the Heraklion port, the data that was collected. Okay, and so we're and I think this is also important to see where does Nautilus and the Ocean IDs get together. What are the synergies? So Both projects have a strong open access data policy, which makes a rich diversity of making a rich diversity of marine data available. Nautilus in situ acoustic and observation system data can be seamlessly integrated with this platform. Both projects have overlapping pilot sites, Azores, Heraklion, and Crete. And also the enhanced observation and coverage. Nautilus has developed a wide range of innovative marine instruments, fluorometric sensors, passive active acoustic sensors, hyperspectral cameras, microplastic samplers, etc. And that can be complemented and enrich Ocean ID's data sets. Combining data sets could also provide a more holistic view of the marine environment and improves both spatial and temporal coverage. And then in maximizing the impact and outreach, the shared data and joint efforts can actually boost visibility and outreach, and also the policy impact across European and international marine research communities. So I think those three aspects are actually quite important in this synergies. And that would be it. Well, thank you.
Thank you, Rui. Yeah, it's a very recent synergy that we started, and we already identified, thanks also to Rui, some areas where we can cooperate and move forward. And so now I leave the floor to Patrick Goringe. Let me just open presentation.
Yeah, put it in the right place.
Yeah, see with your name, please.
Yeah. And that one's on.
Starts like this, okay?
Huh?
It starts.
Yeah, it does.
Okay.
Maybe it's a bit different.
So, Patrick represents the Swedish Meteorological and Hydrological Institute and contributes to this project. He's an experienced ocean science professional with a strong track record in marine data systems, global and European coordination, and the development of observational platforms and international data sharing networks.
Is that me?
Yeah.
Okay, good.
Patrick, the floor is yours.
Thank you. And you mentioned one hat, but I have many hats. Antonio and I share a hat. We do that through eMonet. And I also just wanted to start with this. Antonio, come on, have a look. You remember, right? Yeah. Because Antonio and I actually in 2024, we start to sense that there was like a need around in the community. And we initiated some workshops that started out in Europe, but then we went global. And it went up to that we had at Oceanology International in London. We were part of the EOS Technology Forum. Anyone who's been there to Oceanology know that this is like the big sensors and the big guys, but we brought the low-cost community into that environment. And that was the first time that ever happened. And it was pretty cool because we were presenting on our low-cost technologies side by side with people from Kongsberg or whatever. So that was awesome. We also had a very nice session in Barcelona at the Ocean Decade Conference. So it was something that just got bigger and bigger. And then we sit down after a year of going around to places and saying, wow, there's this massive need out there. There's a need to connect sensor developers to the ocean community, because that was one of the biggest things that we identified. Sensor developers didn't know where do we go with our products and how to reach out to the ocean community. So I took that back to my institute. I pulled my colleague, Emily Brevier, into a room. We had a whiteboard and we had a pen. And then we just went, woof, here's the idea. This is what we should do. And we came up to that, the name, the kind of concept and how to could connect to all kinds of things all around the place. We had that pretty clear. And then Emily came up with Scoop. the solutions for cost-effective ocean observation platform. And we said, yeah, that's what we do. And we started connecting this scoop that is an ocean decade action now. So it's we can have the decade logo on it. We connected it directly to the Ocean Decade Program Coast Predict that we heard of from Viviana. To EMONET, obviously, because any kind of data that will be produced or be seen will connect it straight to EMONET. Jericho to Jericho, that has been going on for quite some, I think for almost, 12 years now, yeah. So that was also linked in. And also to the Lancelot project. I'll show you a slide about Lancelot later on. And through Lancelot, we are now powering Scoop. So we're using Lancelot, and Scoop can be part of the legacy of the Lancelot project later on. And then we met up with Synchro. That's another Ocean Decade action, but it's based in the US, and they were doing exactly the same thing. So what we did was, if we do this in Europe, you do it in the US, let's do it together, and let's build globally instead. So let's think global, and let's find and see what kind of tools we have to try to build this together. And it's been a pretty incredibly momentum going on. Scoop. I have so many things I want to talk about, but I'll be around for these days. So I'm going to limit it to this, basically. It's global, and what we're trying to do then is to connect the sensor developers, the data people, and the data collectors into one place. And this is all about cost-efficient sensors. We want to reach all the way to the sensor developer level to educate them about how we want data to flow. So that's following the FAIR principles, basically. Just guide them on the way, so we, as close to the sensor as possible, have a interoperable data flow, but then we'll go straight to EMONET. This is the kind of idea of it. We have a website. That's the website. Enrique, if you're still online, I also have an iceberg, because that's pretty good to have. So, and I think it was the same iceberg, actually, Enrique. Anyhow, which is good, because there will be synergies with what you do too. So we have the same iceberg. That's perfect. So the idea there is what I said about FAIR, about the data, educating. We have a website that it's in constant, we keep adding to it constantly, but today it's a catalog of cost-efficient sensors. And there are other things that we'll get working on eventually, but currently this is what it is. You can go there. We made an inventory, took the inventory from American colleagues, and then we added that with the European. And then we started to get people all over the world that want to be part of this. We collect the metadata. That's why what you have there, the metadata collected there, it's awesome. It's fantastic. I want everything you do to fit in here. If you want it, we want it to be the kind of marketplace. We want, if there's a new citizen science project popping up, and they say, yeah, we want to collect this kind of data. It would be amazing if they went here, they made their little filter, and they come up with some suggestions on producers that they can contact, and then we could just connect everything. That's the idea with this one. So if you want, go in and have a play with it. There's about 30 sensors in there now, but we have way over 100 in an Excel. We just need to plug it in and find the time to get that in there. Lancelot, yeah. So this project is something that's been running for like a year. And the idea here is to close data gaps in the land-sea area. How do we plan to do that? Well, we're doing that with low cost or cost-efficient sensors. So in the project, we have a budget. We have people in these different regions that you can see. Well, you see the Baltic, and you can see them all over the place in Europe. We have the experts there. In that areas, they're trying to address a specific need. To do that, they need more data. What kind of data do they need? And then we go to Scoop, and we try to find the right sensor for them to deploy in this area to collect the data to answer that specific need. So these 9 regions are key. We have a pretty good one going on just south of Lisbon with Francisco Capuzano, who's running that one, who has a pretty long order of sensors that there's already some of them are there collecting data. Anything that's collected there then goes to EMONET as well. So that's what Lancelot is about. It's also connecting to citizen science initiatives in these areas. If we can identify citizen science activities going on in one of these areas, we try to engage them and get them to help us out to collect the data. That's Lancelot. Viviana, you did a fantastic job to mention CSMAC1. This I believe is going to be a bit of a game change. What we're doing here, we have the kickoff in July. We already have some low-hanging fruit in there. So we already know some initiatives that will be perfect to just pull that in. But we're also reaching out, looking for new citizen science initiatives that are collecting their data. We want to go there. We want to knock on their door. We want to say, hi, guys. If you start doing just this with your data, and we can pull that in and we can put it on a European/global data portal, and your regional or very local initiative would then be seen globally. This is often a carrot that they really like. You go from the local and just elevate it up to global scales. So that's what it's about. This is going to be super, super exciting. Everything actually fits together here. With exactly what you do here, everything that you do fits into everything I've been talking about and much, much more. I need to be here for 2 days and we're going to talk a lot. That's my idea. And this is just some of the things going on. EMONET is all over the place here. Viviana, everything you talk about is here too. We have CSMAC1, we have Coast Predict, we have all these things going on, and it actually fits super well into one package. So it's better that we, further down the line, let's build all this together. Let's do it as one big kind of package of things and bring together these initiatives to sync and just build something pretty cool and pretty big. And my last slide, I'm going to flag for something coming up later this year. There's something called the Ocean Enterprise Initiative. We have if people are aware of it, Goose came out with a number of dialogues with industry that raised a lot of attention. There was dialogues with industry, and they did a dialogues on harmful algae blooms. So that means that I think with the HABs, there was 3 or 4 webinars talking about how to connect things, also including industry. So I got into this group some months ago, and they were looking for the new dialogues, and I said, let's do it on sensors. And they went crazy about it. So this is what we're going to do. We're just about now forming the core planning team for this. And we'll run 3 dialogues in October, November, based on cost-efficient sensors, but also connecting it to the big players around. Where we're more looking for a kind of title that let's build the ocean observing system for the future. And we do that together. So it's not about us and them. It's building everything together. Keep your eyes open on this. And the 3 dialogues will have specific themes. And I would be super happy if people here would like to contribute to those themes. Once they are decided, it would be nice to share that with everyone in here. And you can say that I can contribute to that one. And then you're one of the experts to help us out to run this show in October, November. That's all from me.
Lancelot, we have the procurement.
Yeah. Yes.
Key results from now. So
Yeah.
please fill the forms of scoop because Lancelot is relying on the scoop
Exactly.
list in order to inform the other colleagues when they are applying for cascaded funding and procurement of new tools, instrument to be deployed in the.
Yeah, so scoop is that kind of, so when we have our experts in these 9 areas I showed on the Lancelot slide, they go to scoop and they ask for advice. What kind of sensors can we use? Then they go to ETT, and that's where they make the order for these. So any sensor that's in there that we manage to identify would then be on the agenda of Lancelot to buy. So the sooner, if you have stuff that's up and running and ready, let's pull it in there as soon as possible.
The new wave, end of summertime. So
yeah,
the sooner the better.
Yeah. So anything that is ready to go, put it in there, and then the Lancelot people would say, "We like it. Let's get it."
A very nice legacy of Nautilus.
Very nice.
We can show that what we developing can be early adopted by other projects.
Yeah, that's good one.
Yeah, we tried already sharing the new about Lancelot. People need to be pushed a little bit more. They feel insecure about the maturity of the technology, of course, but
I would just say that last year we just spoke with all the sensor developers that are here about the Lancelot. So, and also with Francisco Campuzano at CTech Week, and trying to see like the scope and the type of parameters you want to measure.
Yeah.
And then we ended up, and then NKE registered the sensor. So we did that kind of process. Maybe it's a bit wider, I don't know now. I think it's a good opportunity since we are here and now we are at the maturity level that we were not last year. So it will be really interesting to see how we can maybe add some more. But I think we already filled the TTT form, that maybe it's the scoop form in the past, or it's a different one.
It's different because I mean the TTT form is the last
from Antonio, the one I got from him.
That is needed in order to
for the procurement.
Yeah, for the procurement.
Yeah.
Okay, so the scoop would be another.
That is, I mean, an inventory that is offered on a.
Okay, so it's kind of okay.
Yeah.
So the scoop we did not share, but we shared in that time, and we registered for procurement.
Okay.
But it's just about maybe joining.
Yeah, and it's been.
Yeah, a sort of reserve list of sensors that we know that they're working, and so when people are asking for a given sensor,
you can just check.
Yeah, we can offer the inventory, and also from the, let's say, procedure point of view, we can also request offers from many providers, because then you always have to provide the cost-effective solution.
No, that was really interesting because we understood the need. So you really need a commercial sensor ready that you can just send a quotation. So a TRL like 5 or 6, it's not still okay for the Lancelot, but maybe for scoop it's okay.
For scoop, it's okay. So
it's different.
Because then we say it, it's pretty much up to the user.
Okay, yes.
Who will go in and
to accept
or not. Exactly. And if you get there, we're building that together with American colleagues, meaning that you're also seen in the US, and it's also gathering a lot of momentum both in Southeast Asia and Africa. So we have people who are really, really keen on this. To be honest, this is, and everything you talked about this morning, this is the hottest topic around at the moment. It's the cost-efficient sensors. It's connecting it with the citizen science on different levels. So citizen science can be, it can be on so many different levels, like we do with the fishing vessel Ocean Observer Network. We're putting sensors on the fishing nets. That's also a kind of citizen science, but it's advanced. Or you can, let's see, I think I have them. I have to. You can just deploy the small little temperature loggers around. I mean, this is how much did you pay? 70 euros, right? Yeah, there are thousands of these all over the full Atlantic collecting temperature data. Or you put this little thing on your fishing rod. This is a probe. It's called probe. Put on your fishing rod when you fish. You get a temperature salinity and you get light from this one. It's so easy. And with people all over the world and all over the coast, this is something we have to use. So it's really, this is where the biggest momentum is going on. That's why we have to keep what you do. We have to keep it going. We have to find a way to keep this going because you created so much momentum.
Well, some other things might just rise tomorrow because we also have a database of
I know.
sponsors of almost 400. So it would be really nice to have a synergy through that.
Yeah. I'm looking forward to tomorrow. That would be cool.
Thank you, Patrick, also for the many inputs that's maybe also useful to the external attendance for these events. So we're now moving to I can stop presenting. So the final part, which is something that it's, let's say, a different aspect, but kind of important in the latest period of European and Horizon projects, and it's about ethics. I think that Nina, are you there? Sorry for slight delay.
No, I'm here patiently waiting for my turn.
Thank you. So as I was mentioning, ethics is underlying in all different projects, and it's underlying all the various aspects that we have seen in the various presentations. And so I will leave the floor to Nina. Nina is a principal consultant in higher education, specializing in innovative learning and research ethics. She lectures at University College London and serves as an ethics advisor on several EU-funded projects. Nautilus, one of them. A fellow of the Royal Society of Arts, Nina's work focuses on integrating environmental ethics into STEAM education to foster interdisciplinary collaboration and sustainability. And obviously, Nina is is in the external advisory board of Nautilus and is the ethics board coordination. And the floor is yours, Nina.
Thank you very much. Thank you for introduction, Gabriela. Thanks for inviting me. And it's been a great pleasure hearing all those amazing presentations and the updates. Greetings from sunny London to start with. So the climate change is definitely influencing all of us. I do not have a presentation. I mean, I'll talk, and I'll encourage you to interrupt me should needed. I don't have a PowerPoint presentation. Nevertheless, I just thought, following all the presentations today, Gabriela, with your little help from time to time, I would like to just give an overview of the white paper that we've started working on in 2023, so in early 2023, and Eva already mentioned briefly in her presentation during this, the citizen sciences presentation of Nautilus project that the white paper is in making. We are getting somewhere. And in a nutshell, the white paper is titled Ethics Protocol in a Multidisciplinary Marine Project, which is Nautilus. And basically, we are looking at a new approach to research and innovation excellence. With regards to that, I mentioned we've started writing the paper. When I say we, it's the Nautilus Ethics Group, which is basically made from the Nautilus partners. It's Gabriela himself and Michaela from the CNR, Eva, who presented the citizen science part today, Manolis, Georges, Christopher, Sandra also had an amazing presentation, and myself. I just would like to clarify that I'm part of the external advisory board of Nautilus. Nevertheless, having specialized in innovative education and ethics, and I've been an ethics expert trained by the European Commission long time ago. So I somehow assumed that the role of ethics advisor of Nautilus. So with that in mind, we started talking about the white paper. We developed, or we drafted the first draft, as I've mentioned already. in early 2023, and we picked it up early this year. With that in mind, and trying to wrap our ethics white paper up, I actually asked Gabriella to send me or resend me the ethics summary report of the Nautilus, and also the original proposal, because all of us, we need to refresh our memories from time to time of what we wrote and what the feedback, ethics feedback was back in the day. And I came across actually two really interesting points I would like to raise with regards to the ethics protocol and the white paper, why we've decided to write the paper, and why we also need your help, which actually today's presentations helped us a great deal. So in a nutshell, just going a little bit down the memory lane, the ethics summary report of Nautilus just highlighted ethical issues for humans, protection of the personal data, animals, third countries, environmental protection and safety, and dual use. Nevertheless, what caught my eye, and I pride myself of being very attention to detail stickler, the ethics summary report was actually sent to us on the 27th of May in 2020. There I remind you that at that day, the whole Europe and the world, planet Earth, was in a lockdown, or the start of the lockdown. So Nautilus is not just a project that is Horizon 2020 funded project, but it basically did go through enormous amounts of change, from a worldwide change in terms of how we work, but also how the Research Executive Agency came back to us with all the documents that we needed. So going back to the ethics summary report, those 6 ethics issues that I've just mentioned, the humans, protection of personal data, animals, third countries, environmental protection and safety, and dual use, were actually addressed, and we needed to follow these rules religiously. And we had to actually, we started, the Nautilus project started with all the theoretical research aspects in order to basically get the project rolling. Nevertheless, quite a few, especially demonstration things, were on hold because of the pandemic. The second interesting part, in my view, that I came model canvassing, and just one bullet point was addressed the algorithm, artificial intelligence based. Sorry, I'm reading here. Artificial intelligence based something. So I apologize for this. And throughout the presentations today, we've actually all noticed that artificial intelligence played a big part throughout the Nautilus. In particular, Eva mentioned, for example, the citizen science app that was used, and many other things with regards to observation and underwater technology and all those things. So if colleagues from Research Executive Agency are still around, please correct me if I'm wrong. Back in the time, artificial intelligence was not part, or it was not a category under the ethics issues. So one more point, or yet another point, why Nautilus ethics protocol and the white paper we are working on is of vast importance, so we can actually document, or we documented, the development of the ethics issues and the importance of the ethics issues throughout all of the projects that are funded by the European Commission. One more tiny little point from the proposal was that basically the Nautilus project or proposal at the time was going to follow the research responsible and innovation concept, or RRI. With everything that we've heard today and with the idea or behind the story of white paper and the importance of ethics protocol in multidisciplinary marine project is also that the responsible research and innovation concept is not just, and dare I say, RRI, but also responsible ethical approach to research and innovation. So we may even be able to do to have a groundbreaking white paper. And for that reason, I really would like to ask you all to help us out and highlight any other ethical issues that we may be able to introduce and write in our white paper. The deadline is approaching quite swiftly. So any reminders of what we can add to our white paper in terms of recommendations would be of great help. And also just to give you a little bit of an insight of the white paper, the content is basically, we started with rationale and Nautilus objectives, and we are going through the 4 case studies that some of the case studies were represented today, starting with the case study of the science citizens that Eva told us some fascinating information of the people involved, in particular children and students. Then the second case study is the use of the platform that is basically more or less led by Gabriella and Michela. And then we have animal welfare that George are helping us a great deal. And also, last but not least, Gabriella, help me out, the 4th.
The dual use and the animal, the dual use items.
Yes, yeah, that's the case study number 3, and number 4, the usage of the dual use. That's the case number 4. So those are our sort of white paper ethics protocols in multidisciplinary marine project that we are actually showcasing the Nautilus new approach to research and innovation excellence. So that's me. I hope this was not too boring, but informative. And any questions, any ideas, please do get in touch, and we'll be more than happy to start and continue the collaboration. Thank you so much. Thank you.
Thank you, Nina. Yeah, you highlighted a very, very important part that since the beginning of our project, we thought that it is underestimated in many projects, but through what we understood from new goals and other projects that have started subsequently, receives more and more highlights and requests of explicit mentioning in the EU goals. So it's something that I think, as you mentioned, we are kind of breakthrough, starting so early with our project, and with your role leading us through this. And hopefully we will manage at the end of the project to provide these guidelines through a white paper and all the ethics deliverables that are foreseen in the project. Because it's very, very important topics that usually it's underestimated by technical and other participants in projects. So thank you all. Thank you. Thank you to all the panelists connected and all the participants connected remotely. We are a little bit of delay. Sorry again for the inconvenience at the beginning with the connection, but you know, these things happens. And I hope and I believe that it was very, very fruitful and interesting. At least for me, it was very, very nice. And we learned everything new from all the participants and speakers today, and wish to have many other occasions like this one today to share in sessions like these with other projects and experts from various and multidisciplinary experts, that because I think it's useful to grow and to bring forward what we all have in common, that is about the environment and the ocean preservation, and improve the situation that we are facing throughout Europe, and not only concerning the issues with the pollution and the climate changes. So thank you all, and we are closing this session now. Tomorrow we'll be going on with the Nautilus Consortium meeting. This is internal consortium meeting. And saluting everybody from the remote speakers, with maybe an applause from the local. Thank you.
Thank you. Bye.
Thank you all. Enjoy Azores.
Thank you.
Bye.
Bye-bye. Bye.